Welcome everyone, my name is Scott and welcome to another Phaser 3 tutorial series. In this series, we are going to be making a simple space shooter game using JavaScript and the Phaser 3 library. Here's an example of the game we'll be building in this series. For our game, we're going to focus on building all of our game objects by using reusable components. And so we're going to start off by adding in our player and adding in support for keyboard input, so then that way we can move our ship around and fire our weapon. We'll add in some nice animations for both our player and our enemies. And so for our enemies, we're going to have two different types. We're going to have one that just comes down the screen, and then one that'll have this wave pattern as it comes down at us. We'll then take a look at how we can handle collisions in our game between our various phaser groups and between our player and enemy ships. Next, we'll work on our enemy spawning, and we'll learn how we can use object pools to handle our resource management so we can easily reuse our game objects in our game. Finally, we're going to wrap up by adding some nice UI components for our player score, lives, and then we're going to go ahead and add some audio to our game. So for this series, some experience with JavaScript and the Phaser 3 library is a plus, but it's not a requirement. For this series, all you'll need is a basic IDE and a local web server to follow along. In this series, I will be using VS Code for my IDE, and I'll be using an awesome extension for our local web server to go ahead and test the game that we are going to build. If you are interested in following along with the code, there will be a link in the description of this video to the starter project template here on GitHub. This starter code template will include all the assets and the instructions you need for getting started. For each video, there will be links to the starting and ending code for that video so you can easily follow along. So before we get started, I want to give a quick thanks to the following artists, since this game would have not been possible without their awesome assets. So Fuzel, Anselmus, and Pixel created these asset packs that are available on itch.io for the various assets that we use in our game. So from Fuzel, we went ahead and used our player ship, this environment pack for our background, and then our enemy ships. For Anselmus, we use the audio from his project template, Warped. And then finally, we have this nice space background here by Pixel that we use for the background of our game. All right, before we get started with our project, let's take a quick peek at the project task list and review the tasks that we will need to do in order to build our game. So included in the project template, there will be a link to this project task list. So the first thing we're going to do is we're going to work on setting up our project. So we'll go ahead and grab our project files. We'll see how we can run the project by using a local web server. Then we'll go ahead and review our project code, and we'll work on updating our basic Phaser game configuration for what we need for this game. And then finally, we'll go ahead and start doing some code planning for how we want to build out our various game objects, so like our player and our enemies, and the components we'll need to create those. Then we'll go ahead and jump into our code. And so what we'll do is we'll start with our player. And so we'll create our Phaser 3 game objects. We'll work on adding some animations for our player's ship. And then we'll start building out our components for allowing our player to move in our game by listening for the built-in Phaser keyboard events, and then we'll use that to move our Phaser 3 game object. Finally, we're going to take a look at adding in a simple weapon, so then that way our player can fire bullets at our enemies. Once we have that, we'll start building out our enemy classes, and so we'll have these simple Phaser 3 game objects, very similar to player, where we'll have our animations, but for input, we're going to go ahead and have some basic AI movement, where one of our enemies is just going to come down our screen, and the other one's going to do a wave pattern. And so we'll look at how we can abstract some of that logic out so we can easily create different enemy types quickly. Once we have our player and our enemies, we're going to work on adding in simple collisions between our enemy game objects and our player, also between the various ships and the bullets that'll be fired in the game. Then we'll take a look at adding in a health component, so then that way our player's ship can take more than one hit before it's destroyed. Then we're going to go take a look at how we can spawn our enemies. And so we're going to go ahead and look at phaser groups and how we can use these phaser groups to create an object pool. Then that way we can spawn multiple enemies in our game and reuse our game objects. Then we'll go ahead and update our collisions to go ahead and work with our enemy groups. And then we'll also go ahead and add in support for when our enemies are destroyed. We're going to go ahead and have explosions show up on our screen. Finally, we're going to go ahead and take a look at an event bus component so that we can easily communicate between our various components for different things. Then we're going to go ahead and wrap up by working on our UI and our audio. And so we're just going to add some simple backgrounds to our game. We're going to implement mechanics like scoring and player lives. Finally, we're going to go ahead and add some audio to our game. So we're going to add things like background music, sound effects for when a ship's destroyed, we shoot bullets, and things like that. All right, so for our task list, the first thing we need to do is we need to go ahead and download our basic project files. So in the description of this video, there's going to be a link to this page on GitHub and the direct download for the starting code template. So the starting code template is going to have all the assets we need for the game we're going to build, as well as the basic structure for a Phaser 3 game. So if you are interested in following along with the code in this video, please go ahead and download that now and pause the video and come back once you have the assets. All right, so once you've downloaded the files, go ahead and extract those and open them in your IDE of choice. And if you go ahead and open up those files, you should see a folder structure similar to this. And so what we're going to see is we'll have a basic README that's going to have some links to a playable demo of the game, a local setup for running the game, as well as information on how to play the game and links to the assets that are used. We'll also have our project task list if you want to go ahead and use that to follow along. And then we'll have our basic index.html page, which will be our main entry point for our web application. And so this is a very basic web page with some styling and a background. And then we also have a link to our main module file that we'll be using for starting our game. That will be our main.js file. We also have a link to the Phaser 3 library. So for this series, we're using Phaser 3.80. And so if we go ahead and take a look, so in our folders, we have VS Code. So this just says some recommendations for plugins if you're using VS Code. If you're not, we can go ahead and delete this folder. There's also some launch settings for the extension we'll be using for our dev server. Then finally, in our settings JSON, this just has some configuration for the VS Code IDE. Inside our assets folder, this is going to have a link to all the assets we'll use in our game. So we'll have our audio, we'll have some JSON data, our images, and then we'll have a link to the Phaser library. Then docs, this just has assets that's used in our README. So then finally we get to our source folder, and this is where we'll be doing all of our code for our game. So our main.js, this is the main entry point to our application. And so this is going to create our Phaser 3 game instance, and then we'll go ahead and add our scenes and start our game right away. Our types folder has our Phaser type definitions and this type.def.js file here that can be used for JS docs if you are interested in using that for your code. Finally, we have our Phaser 3 game scene, and it's just a very basic scene right now. Where we just print out hello world. And then finally under lib, we just have a reference to the Phaser from the global window object, so we can use that to import in our code. All right, so the next thing we need to do is we need to see how to run our project on a local web server. And so in order for us to actually do our development and to load our assets in our game, we need to have our assets running on a local web server for security reasons. And so to do that with VS Code, there is this awesome extension from Rick Day called Live Server. And I definitely recommend checking it out if you've not seen it before. But basically what it does, it allows you to launch a web server from your VS Code IDE, and it has some simple support for doing live reload as you're editing your files. And so if you go ahead and add that in, what you should see is a new button at the bottom of your IDE where it'll allow you to go ahead and launch your live server, and then you'll be able to take a look at the project. Another way to go ahead and run it is if you open up your command palette in VS Code. If you take a look for a live server, you can go ahead and open it up that way as well. So if you're not using VS Code, you'll just need to have another way to go ahead and run your local web server so you can actually take a look at the project template and to test your code and follow along. So if we go ahead and launch live server, what we're going to go ahead and see is we're going to see this here where we have our basic Phaser 3 game. So we'll have the space background. We have our canvas element, and right now we're just printing out hello world. So then in our browser, if we go into our developer tools and open up our console, we'll see our Phaser 3 banner, and we're using Phaser 3.80. All right, so next we're gonna go ahead and work on updating our game configuration. So currently we have our game already set up for the configuration we'll need for this tutorial series. However, there's a few things I wanted to go ahead and call out in our main.js file. So when we create our Phaser 3 game instance, one of the things we can do is we provide a configuration that'll help set up and configure our game. And so one of the things we've already done is we went ahead and enabled physics for our Phaser 3 game, and we're using the default built-in arcade physics system. And so what this does, this enables the Phaser 3 arcade physics system in our game. And this allows us to create physics type game objects, so then that way we can move them by setting like our velocity. We'll have them move around our scene. And so when we configure this, one of the things we can do is we can specify the gravity for both X and Y. And then finally, you can go ahead and enable debugging. So while we're working on our game, I do recommend setting this to true. What this is going to do is when we create our Phaser 3 game objects, it's going to show our physics body as well as the direction that our game objects are headed. And it just makes it very helpful while we're developing our game. And then before you launch your game, you'll want to go ahead and set this to false, so then that way it's not visible to your players. Finally, we went ahead and targeted our canvas for our game type, and then we went ahead and added support for pixel art. So when you do use pixel art, it's recommended to set this to true and set round pixels to true. That way it just looks very crisp when we render out our game assets. All right, so the last thing we need to do for our project setup is we're going to do some planning for our code. And the approach we're going to take for this game is we're going to try to encapsulate as much of our logic as we can for our various game objects into reusable components. And so what we're going to try to do is build out these components that we'll be able to share across our various game object types, such as our player ship and our enemy ships. And we want to try to make this logic reusable. And then that way we can reuse these components in other game types. So as an example, for our game, we're going to have our main player ship, and then we're going to have a few different enemy variety types. And so for these game objects, we're going to let Phaser be responsible for rendering out our game objects, and we're going to use the built-in classes to construct most of our logic for these classes. So as an example, our player ship is going to be made up of multiple sprites, and so we'll be using the Phaser container game object to put all these sprites into it and let Phaser control that container. But what we're going to try to do is reuse some of that Phaser logic for like our keyboard input. We're going to extract this away into a component, then that way all that logic is together and we can easily reuse this in other games. And so for our two main game object types here, our player and our enemy, they're going to have a lot of things in common, and by putting this logic in one central location and attaching it to our various game objects, it allows us to reuse that logic across multiple classes. So as an example, for our player enemies, if we talk about movement, what we're going to want to do is we want to be able to support both vertical and horizontal movement in our game. And so for our player ship, we're going to want to be able to support horizontal movement, so moving left and right, but we're going to lock our players so they can't actually move vertically, versus some of our enemies, they'll always be moving down the screen towards us, and so they'll always have vertical movement. But then one of our enemy types, we can add on this additional horizontal component, and then that way we get a brand new enemy type that can move vertically and horizontally. And by putting this logic into one component, we can now share that code between these two classes. So besides our movement, we're also going to need some type of input so that we know how to move our player and our enemies. And so we're going to build a generic input component that we'll be able to extend into other components, like a keyboard input component that's going to listen for our keyboard events through Phaser. And that's going to go ahead and set our input so we know if the player is trying to move up, down, left, or right. And so for our enemies, they're going to have a special input component. Basically, it's going to be a very simple AI, and it's going to be responsible for having those enemies simulate pressing the keyboard in the direction they want to move. So for example, this enemy here, because they're just moving down the screen, they'd be pressing the down key. And because they do support a weapon, they would also be shooting at us. Versus this enemy AI here, they're going to be moving left and right, and so they need to alternate between those two states, and that's where this input component will come in. Besides that, we're going to add a weapon component, so we'll just have a basic weapon that the player and one of our enemies can fire to fire bullets, and then this would be reusable, and we can extend it later if we wanted to do weapon power-ups and different things like that. We'll go ahead and add in a health component for all of our game objects. So then that way we can handle our players being hit more than once, and they'll have a life, and as they take damage, eventually their ship would explode if they take too much damage. To work with that, we'll also have this collider component, so then that way we can track when our player or enemies collide with like an enemy bullet or an enemy ship, and then that way we can handle it accordingly. And so besides these key components here, we'll also be adding some additional components that are going to help enhance our gameplay. So one example is for our enemies, we're going to create this enemy spawner component where it's going to be responsible for spawning more than one enemy in our game, and it's going to use an object pool from Phaser. And so this component's job is going to be to constantly spawn out new enemies based on some type of interval. And by creating multiple instances of this component, we can now spawn different enemy types, and we can easily extend this later to add more enemies. Besides that spawner, we'll also create one for when enemies are destroyed. And so this will also be an object pool, but what it's going to do is when an enemy dies, we're going to go ahead and play an explosion animation where the enemy was actually exploded. And in order for this to work, we're going to add this new component for our events, and basically it's going to be an event bus that's going to allow our components to communicate with each other and to communicate with our overall game. So as an example, we're going to pass this component to our enemies, and then that way when our enemy is destroyed, it can emit an event that this spawner can listen to, and we'll be able to go ahead and play that animation. Likewise, when the enemy is destroyed, we can also have like an audio manager listen for that, so we can play a sound effect when that event happens. And so this is just a high-level view of some of the components and how we're going to structure them in our code base. And so this will make more sense once we dive into our code and we start covering these one by one. All right, so the first thing we need to do before we start creating our player is we need to load in our assets we'll be using for our game. And so in our assets folder, we'll have our audio files, we'll have some JSON files, images, as well as the Phaser 3 library under JS. And so for us to go ahead and use these assets in our game, typically what we'd want to do in our Phaser 3 scene is we would have a preload method like this, and we would go ahead and use our Phaser 3 loader plugin to go ahead and tell Phaser what type of file we're looking to load, and then provide a configuration so we can go ahead and cache that so we can use it later, as well as any other settings that we need for that file type. So for example, if we're using a sprite sheet, we'd provide our frame width and height so Phaser knows how to cut out the various frames for our sprites. And so if we do this dot load, this references our Phaser 3 loader plugin. And then what we can do is there's a bunch of built-in methods for our various file types. And so like if I want to go ahead and just load a simple image, I can do this.load.image, and now we can provide our key, which will be the unique identifier for this file. And this is how Phaser will store this in our cache. And so this is important because in our game, Phaser is going to go ahead and just load our asset one time, and then we can use it in our various scenes by grabbing it from the cache. And then that way we don't have to reload this every time we switch between our various scenes. So after our key, what we want to go ahead and specify is our URL to our asset. And so for us, this would be like assets, images, and then the path to the particular image we're looking to load. And this is one way we can go ahead and load in assets. Another way we can do it is if we have all of our assets defined in a JSON file, we can use our pack method to go ahead and do similar functionality. And so that's what we'll be doing for this is we already have this assets JSON here. This is an array of objects, and for each object there is a reference to a path to our assets. So we'll see we have assets, images, and then Foozle. And then under that we have all of the files that are under that path that we need to go ahead and load. And so how this works is we specify the type of file we want to go ahead and load. And so we have like images, sprite sheet. Later on, we have like audio, and then we have our key. So for our cache, the same key we talked about before, and then we have the URL to that asset. Now, because we provided this path here, we don't have to provide that full path in our URL here. We can just go ahead and say scout PNG, and then Phaser is going to use this for a prefix for all these files listed here. And then likewise for like our sprite sheet, this is the additional configuration I was referencing where we provide our frame width and height. And so this JSON file has all these various assets that we'll be needing for our game. So then we also have our audio. And so what we're going to do is we're going to go ahead and load our assets by using our pack method. So in that way we have to specify this one file, and then Phaser is going to go ahead and automatically load in all these assets for us and configure them in our cache. So we don't have to do that manually. And so to go ahead and do this, we're just going to go ahead and do this.load, and we'll use the pack method. And now we can go ahead and provide our cache key for this JSON file. And so I'm just going to go ahead and call this asset pack. And then we need to go ahead and provide the path to this. And so this is going to be under assets, data, and we'll do assets.json. All right, and so once we do that, our game should refresh and nothing changes because we're not actually doing anything within our game currently. And so what's happening is Phaser is adding this to our queue of files we need to go ahead and load. It's going to go ahead and wait until all those files are loaded before it triggers our create method from our Phaser 3 scene lifecycle. And so once we have those assets, what we should be able to do is we should be able to use those assets to add game objects to our scene. So as an example, if I do this.add, and I'm going to go ahead and add an image game object. And let's say if I just want to go ahead and position this at 100, 100. So this is going to our X and Y value. So anytime we want to position a game object in our scene, we need to provide our X and Y coordinates. And so X is going to be how far over we come into our canvas element. Y will be how far down we come into our canvas element. And so if we do 100 by 100, and I'm just going to go ahead and reference ship. And so this texture, this needs to reference one of our assets that we have in our cache. And so if we take a quick look at our assets JSON, when Phaser loads this in, it's going to have this key here. And so we have like scout, fighter, and then we have ship engine. So if we take a quick look, we should see a ship down here for our key. And so this will be the asset that we're using for this image here. So now if we go ahead and save, what we should see over in our browser, we should see this new image show up on our canvas element. So now we've seen how we can go ahead and load in our assets. We're going to go ahead and refactor our game a little bit to actually have this located in a different scene. So what we're going to end up doing for our game is we're going to go ahead and have three basic scenes. And we're going to have a boot scene, we'll have a preload scene, and we're going to have our main game scene. And so what's really cool about our Phaser 3 game is we can structure this however we want. But what we're going to end up doing is we're going to use these 3 different scenes for loading in our assets in our game. And so like our preload scene is going to be responsible for loading all of our assets and doing this here. And so typically in games, this would be like where we'd have like a preloader or just a simple loading screen and say, hey, something's happening, instead of just showing a blank canvas to the player. And so what will happen is if we have a slow internet connection, or if we're loading a large number of files, or files that have big file sizes, Phaser's not going to do anything until all those assets are loaded and nothing will be visible to the player. And so by placing this in a separate scene, what we can do is we could load in some assets we want to show in our preload scene. So just like very small ones like that preload image or a loading icon. And then we can display that in our preload scene while we wait for all these assets to go ahead and load. Then once all those assets are loaded, we can transition to our next scene and we'll have it start automatically. And so to go ahead and create this type of structure, what we're going to go ahead and do is in our source folder, let's go ahead and add in 2 new scenes. So first, let's add in our boot scene, and then we'll go ahead and add in our preload scene. So then what I'm going to go ahead and do is I'm going to come back to our game scene and get rid of that. I'm just going to copy all of my code. I'm going to place it in boot, and I'm going to place it in preload. So in preload, we're just going to go ahead and update our class name to be preload scene, and we'll go ahead and update our key for our scene here. And we will go ahead and get rid of this code in our create method. So in our create method from our preload scene, what we'll want to do is once this is invoked, we'll want to go ahead and just transition to our game scene. And so to do that, we can reference our scene manager by doing this.scene, and then we can go ahead and call the start method. And what that's going to do is it's going to start the Phaser scene we provide. The key is going to go ahead and shut down this scene. So that way only our game scene will be running. And so what we'll do is we're going to reference game scene. And then what we'll do is let's go ahead and just copy all that. We'll come over to boot scene and we're going to go ahead and update our class name. So we'll have boot scene. Go ahead and paste that here. And we want to go ahead and start our preload scene instead of our game scene. All right, so the next thing we'll need to do is now that we've created these new scenes, we need to tell Phaser about them. And so to do that, we'll jump over to our main.js file. And what we need to do is we need to add these scenes to our Phaser 3 game. And we can do that by doing game, our scene manager, and then we can use the add method to add it to our scene manager. And so this is how we're adding our game scene here. So we're just going to copy that line of code. We're going to go ahead and paste it twice so we can add in our new scenes. So first we'll go ahead and add in our boot scene, and then we'll go ahead and add in our preload scene. So we'll go ahead and update our keys so we have the right references. And now we want to go ahead and change which scene actually starts. And so we're going to go ahead and go right into our boot scene. So once we do that, it doesn't look like anything changed in our game, but what's happening under the hood is first we're jumping into our boot scene, we're loading in our assets, then we're immediately going to our preload scene, and then from there we're jumping over to our game scene. So just to see an example of this, I'm just going to throw in some console log statements real quick so we can see this. So I'm just going to do boot, we're going to copy that, we'll jump over to preload scene, we're going to change this to preload, and then we know our game scene is working because we see our ship and our hello world text. So now back in our browser, we're going to see boot, and we're going to go ahead and see preload being logged. And so because we're not using that many assets and we've already loaded them in our browser, they're likely cached. And so we have these very fast reload time here, and we see our transitions are happening very quickly. All right, so real quick, just going to go ahead and clean up those console logs. All right, so now we loaded in our assets. The next thing we do is we're going to go ahead and work on creating some of the animations we'll be using in our game. And so this will be like the explosion animation where our ship is destroyed. We'll see our ship engine thruster, so it'll be like animating as our ship is flying around and things like that. And so for creating animations in your Phaser 3 game, what you have to do is you need to provide your animation configuration, which generally consists of which asset you want to use, so which sprite sheet, things like your frame rate, if you want it to repeat infinitely or a number of times, your frames. So if your sprite sheet has multiple different animations on it, you can specify which frames make up that animation and different things like that. And what we've done for this game is we've created this animations JSON file here that has part of the configuration we need to create these animations. And so what we're going to do is we're going to use this JSON file to programmatically create the configurations we need. And then that way we don't have to manually do all this through code. We can just use this JSON file here to help us get started. And so to go ahead and do that, what we need to do is we need to load this JSON file into our Phaser 3 game. And once we do that, we can go ahead and reference that from our cache and then go ahead and create our animations from this. And so this is another reason we went ahead and created this boot scene here. Is typically we use this scene to load assets we need to reference in our preload scene. So as I mentioned before, this could be like an animation for like doing a loading screen. But for our use case, we're going to go ahead and load in our animations JSON file. So then that way in our preload scene, after we load in our assets, we can go ahead and create those animations and we'll have them all ready to go before we get to our game scene. So to make this happen, we just need to go ahead and change which type of file type we're loading. And so we're going to go ahead and use the JSON method to go ahead and load a JSON file in our preload method here. And so we're going to go ahead and change this to animations JSON just so it has a unique key for our cache. And now for our path, it's going to be assets, data, and this is going to be our animations JSON file. Then for transitioning to our preload scene, nothing will change here. And then what we can do in our preload scene is now, because that file has been loaded, it's available in our cache by the time we get here, we can go ahead and reference that. So what I'm going to do is I'm going to make a brand new method for creating our animations. And so I'm going to make this a private method. I'm going to call it create animations. And what we're going to do is we're going to grab this from our cache and then we'll go ahead and take a look at it. So let's make a new variable. We'll do const, we'll do data. We're going to set it equal to this. We'll reference our cache manager. Then we'll go ahead and reference which type of file type we want to grab from our cache. And so we want to go ahead and grab our JSON. So when Phaser loads in our various assets, it's going to put them in the cache by their like file type. And so like this is how we can grab like our textures, our text, and different things like that. And so we're just going to go ahead and grab our JSON. And then we need to use the get method. And what this allows us to do is we provide the key to the item from our cache that we want to go ahead and pull. And this is just going to be this key here that we provide when we load in our files. And so this will be our animations JSON. And then what I'm going to go ahead and do is I'm going to do a console log and we're just do data. And then what we'll do is before we start our game scene, let's just call our new method inside our class. So now what we'll see over in our browser is our game still loads, but we'll see this array of 10 objects. So this just has all the animation configurations that we had specified in our JSON file here. So now that we know how to grab those objects from our cache, what we can do now is we can go ahead and create our animations. And so what we're going to do is we're going to go ahead and loop through our array of objects. So we'll go ahead and do data. We'll go ahead and do for each. And then so in our for each loop, we'll go ahead and just reference our animation configuration. And now what we want to do is now we need to go ahead and create our animation. And we do this by doing this. We're going to do anims to reference our animation manager. And then we use our create method to go ahead and create an animation and then store it in our animation manager. So to create an animation, we need to provide our configuration. And so this is going to consist of a key. So this is the unique key to reference this animation config from our animation manager. So similar like to the key we use for our asset cache. And so this key needs to be unique for each animation. And so what we're going to do is we're going to reference our animation and then our key property on our object. Next, we need to go ahead and specify our frames. And so we'll come back to that in 1 second. I'm just going to do an empty array. Then we want to go ahead and reference our frame rate. And so this is going to be our animation frame rate. Then we'll go ahead and do repeat, and this will be our animation.repeat. And so now for our frames, this is going to be an array of frame configuration objects. And so it's not just going to be an array of numbers like that we see here. Instead, it's going to be an array of objects that's going to have each frame that we need for this animation. And so to create that, Phaser has a number of built-in utility functions we can use to generate that configuration. And so typically what that looks like, this is going to be this.anims, and then we do generate frame numbers. And now what we can do is we can specify the asset key to our sprite sheet of the frames we want to use, and Phaser will dynamically create this array of objects that we need. And so what we're going to do is we're going to use this, and we're going to base it off of either if we specify our frames here, or if we don't, we're going to let Phaser create that for us. We have to do it manually. And so to go ahead and do that, we'll make a new variable, do const frames, and then we're going to go ahead and reference animation and then dot frames. And so now what we'll do is we'll do our turn operator. So then that way, if it does exist, we'll use that property. If it doesn't exist, we'll do different logic. And so what we'll do is we'll do this dot anims, we'll do generate frame numbers. And now what we need to do is we'll do our animation, and we want to reference our asset key. And so when we do this, this is going to be the key of the asset of our sprite sheet that we're referencing. So for a lot of our examples here, we kept this the same. But like as an example, our explosion, we're using the same Scout Destroy sprite sheet as our Scout Destroy animation here, but it's using a different subset of frames. And so after we provide our asset key, now we need to go ahead and provide our frames. So this is going to be an object with frames being an array of numbers. And so we'll do our animation frames. And so if that property does not exist, then what we want to go ahead and do is now we just want to go ahead and call our generate frame numbers with just our asset key. And then Phaser is going to go ahead and automatically just use all of the frames from our sprite sheet to generate this array. So now what we can do is we can go ahead and pass in frames here to our configuration. All right, so after we save, our game should reload and we should see no errors in our console. And so now if we want to go actually test this, what we'll do is let's jump over to our game scene. And we're going to go ahead and play one of our animations just to make sure everything's working. And so to go ahead and use animations with our game objects, we want to go ahead and change our game object from image to be a sprite. And so the sprite game object allows us to play different animations for our various sprites. So what we can now do is on our game object, we're going to have this play method, and we can go ahead and specify the key of one of our animations that we like to go ahead and play. So just as an example, if I go ahead and copy this key for explosion, we're going to go ahead and play that animation. What's going to happen is our scene's going to refresh, and right away, we'll see that our explosion animation plays for our sprite. And because in our configuration, we go ahead and have that repeat 0. So that means it's going to play one time. So our explosion stops. And so now if we bump this to something like -1, it's going to go ahead and repeat indefinitely and just replay that animation. So likewise, like if we go ahead and copy like Scout Engine and we play that animation, we should see that animation play in our scene. And so what I'm going to go ahead and do is we're going to go ahead and get rid of our play method, and we'll just leave this as our ship. So now we have all of our assets and our animations we need for our game. We're going to start creating our game objects. And so we're going to go ahead and start with our player. And so what we're going to do is we're going to move our game object that we're creating here for our sprite from our game scene. We're going to create a new class to represent our player object. And it's going to be responsible for constructing all of the components that we'll need for our player. And so to go ahead and make this happen, what we'll do is let's go into our source code folder. We're going to go ahead under source, we're going to add a new folder. And so we're going to go ahead and call this objects. And then under objects, let's make a new file. We're just going to call this player.js. So what we'll do is let's go ahead and export our new class. We'll do export class. We're going to call it player. And we're going to go ahead and extend our phaser game objects. And we're going to go ahead and do the container game object. Okay, so for our player class, we're going to go ahead and extend our phaser game object container game object. And basically a container game object is a way for us to group game objects together. I don't want to confuse this with a phaser group because they're two different game object types. But basically what the container allows us to do is we can position objects within this container relative to that object. And so this is a really good use case for us because what we're going to end up wanting to do is for our player ship, it's going to be made up of multiple assets. And so we have our main ship here that we see. We're going to also have our engine, which will be this game object here, this image will go below it. And then we're also going to have this thruster that's going to animate to show that our ship is actually moving through space. And so having to keep track of all these objects individually and have them be in the same position as our player as it moves around, it can become cumbersome. And this is where the container really shines, because if we place all of these inside one single container, we're just going to get like this box. And now we can just move that box around, and Phaser is going to go ahead and move all of those game objects for us, and we don't have to do it manually. And so it's a really nice way to group them together. All right, so the next what we'll do is let's go ahead and add in our constructor. And so for our constructor, we're going to have one argument, and this is going to go ahead and be scene. So this is going to be our Phaser 3 scene that we want to add our game object to. And so because we are extending this class here, let's go ahead and use the super method. We're going to go ahead and call our parent class. And so for the Phaser 3 container game object, we need to specify our scene. So this will be the scene that we pass in. And now we need to do our X and Y properties where we're on our container positioned. And so what we're going to do for our ship is we're going to position at the bottom of our screen. And so what we're going to do is we're going to reference our scene, we're going to reference our scale manager, and we're going to reference the width property. And what this is going to do is going to give us the full width of our canvas game. And then that way what we can do is we can divide it by 2. And that's going to position our game object right in the middle. Then we want to go ahead and position it towards the bottom of our scene. So we can do a similar thing with our scale manager. We can go ahead and grab our height. So that's going to give us the full height of our game. And now what we can do is we can just subtract, we'll say 32 pixels. So that way we bump up our game object a little bit here. Then the last thing we can provide for our container is if we have any game objects that already exist, we can pass them in this array here, and Phaser will automatically add them to our container. So we don't have any game objects right now, so we'll just go ahead and pass in our empty array. So now what we'll do is let's jump over to our game scene, and what we'll do is let's get over our hello world text, and let's make a new variable. Do const player. We're going to set equal to new player. We'll pass in this scene reference. And let's copy this logic here where we add in our ship sprite. We're going to go ahead and jump over to our player class, and we'll go ahead and paste that here. So now what we'll go ahead and do is we need to go ahead and update this to create our ship sprite. And so what we'll do is we're going to create a property to keep track of this. And so we'll have ship sprite. And so it's going to be a private property. We'll do this. Our ship sprite is going to be equal to this.add sprite. And so instead of doing this, we want to reference our scene that we have here. So we'll have scene add sprite. And then for positioning, because we're positioning our container, we want this to be positioned relatively in our container. So we're just going to do 0, 0. And then we need to go ahead and add it to our container. So we're going to do this. We'll do add. And now we can provide an array of game objects. And we're just going to do this. And we'll reference our ship sprite. So one last thing we need to do is when we extend one of the built-in Phaser 3 classes, we need to go ahead and add that game object to our existing scene. And so to go ahead and do that, we'll just do this. We'll reference our scene. And then we're going to go ahead and use the add method. And we want to go ahead and do add existing game object. And so what this is going to do is Phaser is going to add an existing game object to our scene. And so inside here, we just specify this to reference our Phaser 3 game object container here. So once we do that, our player ship should show up on our scene in the position that we specified for our container. All right, so one thing to know is when we add our game objects to our container, our positioning is relative to our container. Because we specified 0, 0, our ship sprite is going to be added at the same position that was used for our container. And so if I do something like this, where I make this like 30, it's going to go ahead and move our ship 30 pixels over from wherever that center of our container is. So it's not going to go ahead and do 30 over from here, from 0. It's going to do 30 from our origin of our container. And so with that, we can do different things. Like if we want to position this like outside our container, we can do that. All right, so now we're going to go ahead and add in our two other sprite game objects for our player ship. And so we're going to go ahead and add in our ship engine sprite. So let's add new properties for this. And we'll have our ship engine thruster sprite. So then for each of these, we're going to go ahead and add those sprite game objects to our game. So we're going to copy this line here and paste it twice. So we'll have our ship engine sprite, and we'll have our ship engine thruster sprite. So for these, we're going to go ahead and position them all at 0, 0. And so we'll have our ship underscore engine, and then we'll have our ship underscore engine thruster. So now we're going to go ahead and add those to our container. And so what we're going to go ahead and do is we'll do this. We'll do our ship engine sprite, and we'll do our ship engine thruster sprite. So one thing to note is when we add our game objects to our container, they're going to be rendered in the way that we add them to our container. So because we added our player ship first and then our engine sprite followed by a thruster, you can see our player ship is now covered up based on these game objects. And so one way to handle this is we could set the depth of each object so they're different, or we can go ahead and just modify the order we're adding them to our container so we have the display we're looking for. So what we're going to go ahead and do is we just want to go ahead and reverse this. I'm just going to copy these two. We'll have our thruster sprite be on the bottom. Then we'll go ahead and let's just copy this. We'll have our engine sprite, and then we'll have our player ship. So now when we save, our scene's going to refresh, and now we're going to have this nice looking ship here. We have our player ship, followed by our engine, then our thrusters. All right, so then the last thing we're going to do is let's go ahead and play our animation for our thrusters. So let's reference our ship engine thruster, a game object. We'll call the play method, and then we're going to go ahead and specify our animation, and we'll use the same animation name as our asset. All right, so go ahead and save. We should now see our thruster animation is playing. So now that we have our phaser game objects, our container representing our player's ship in our game, the next thing we need to do is we need to start adding in our components that we previously discussed. And so the first one we're going to start working on is going to be our input components, so then that way we can move our ship around our scene. So in order to do this, we'll be using the Phaser 3 cursor keys game object. And what this is an object that's going to allow us to listen for keyboard events from our arrow keys, as well as the space key for our game. And so to see an example of this, what we're going to do is in our game scene, let's go ahead and make a new variable, do const. We're going to go ahead and do cursor keys, and we're going to set equal to our scene. So we'll do this, we'll do our input manager, we'll do our keyboard plugin, and then we'll go ahead and do create cursor keys. And so what this is going to do, this is going to create an object with the properties for each of our arrow keys as well as our space key. And now what we can do is we can go ahead and listen for this in our update event on our scene. And so let's go ahead and just store a reference to this. So we'll do this, our create cursor key, our cursor keys, and then we'll go ahead and add our update method. And now what we can do is in our update method, we can go ahead and check to see if any of our keys are actually being pressed. And so go ahead and see an example of this. What we'll do in our update method is let's go ahead and add a console log statement, and we'll go ahead and do this. We'll reference our cursor keys. And so this is going to be an object with our various keys. And so we can reference the up property to reference our up arrow key. And then these are going to be objects with different properties on them, and one of them is down. And so this is a Boolean value that will be set to true if we're holding the key, and it'll be set to false if it's not being pressed down currently. And so what I'm going to go ahead and do is I'm just going to copy this. I'm going to paste it a few times for each of our arrow keys, just so we can see an example. And so we'll have up, we'll have down, let's do left, let's go ahead and do right. So now we'll see in our console log, we're logging false because I'm not pressing any arrow keys. And so if I go ahead and press up on my keyboard, we'll see that's true. Down, we'll see the second one's true. Left, and then right, we'll see that we toggle each of those keys. And so this is just a nice shorthand method to go ahead and add listener events for each of these keys. And then we can go ahead and use this object to check their state. And so now that we know how the cursor keys object works, what we're going to go ahead and do is we're going to go ahead and build a component to go ahead and have all this logic be located inside. And so what we're going to go ahead and do is let's go into our source folder. We'll go ahead and we'll make a new folder. We'll go ahead and call this components. And so under here, we'll make another subfolder. We're going to call this input. All right, so the first one we're going to go ahead and do is we're going to go ahead and create a generic input component. And so this component's going to have an abstraction for these key presses here. So like up, down, left, and right. And then that way we can have different implementations of this input component. And one of them is going to be this keyboard input component where we'll use our cursor keys. And so this is going to allow us to reuse that logic for our enemies because our enemies don't need to react to our keyboard presses. They need to go ahead and handle input in their own way. And we'll get more into that once we build out our enemy classes. So for our generic component, let's go ahead and add a new file. We'll do input component.js. And so what we'll do is let's go ahead and export out a class. We'll export class. We're going to call this input component. And so on our component, we're going to need properties to track our arrow presses as well as our space key. And so what we're going to go ahead and do is we're going to go ahead and add these properties that we're going to have them be protected, which means they should only be referenced within this class or our child classes that extend this class. And so what we'll do is we're just going to go ahead and do up, we'll go down, let's do left, and we'll do right. And we're just going to go ahead and call this one shoot instead of space. And so what we're going to go ahead and do is let's add our constructor. And so our constructor is going to be responsible for setting all of our initial values for this. But what we're going to do is we're going to go ahead and put that in a method so that way it's reusable. And so what we're just going to do is we're just going to call this. We'll make this a public method. So let's go ahead and do reset. So now what we're going to go ahead and do is let's add that method. And for each of our properties, and so we'll do up, we're going to go ahead and set it equal to false. And we'll go ahead and do the same thing for each of these. And so what this method will be doing is in our constructor, it's going to go ahead and set our initial values, but then later on, we could call the reset method from another class to go ahead and reset these initial values. And we'll also be able to reuse this in our child classes that we'll create soon. So the last thing we're going to go ahead and do for our properties is we want to have a way to go ahead and return these values. And so because we do want this to be protected, we're going to go ahead and add getters to go ahead and return these values. And so to go ahead and add our getter, we'll do get. We're just going to do left is down. And then what we'll do is we're just going to return this and then our left property. And so we'll do this for each of our fields. And so let's go ahead and paste this a few times. And so we'll have right is down. We'll go ahead and have down is down, up is down, and then finally shoot is down. Then we just need to update our references. We'll have shoot, we'll have up, down, and then right. All right, so that gives us the basis for our generic component. And now what we can do is now we can create implementations of this component and tie that to our core logic. So what we're going to do now for our keyboard input that we did here, we're going to go ahead and create a new component that's going to go ahead and create this logic here, and then go ahead and set our values inside our component that we create. And so what we're going to go ahead and do is let's go ahead and make a new component. We're going to go ahead and do keyboard input component.js. We're going to do export class. We're going to do keyboard input component. And we're going to go ahead and have this extends our input component. So for our input, we just want to make sure we have .js. So then what we're going to go ahead and do on this component, we're going to go ahead and create our cursor keys. So just go ahead and copy this from our game scene, and we'll add that as our private property here. Let's go ahead and add our constructor. And so in order to create our cursor keys, we'll need our phaser scene. And so that'll be one of our only argument. And then what we'll do is we'll call our super method. So we'll go ahead and call our parent class. We don't need to pass anything. And now we can go ahead and create our cursor keys instance. And so that's going to be our scene, input, keyboard, and we'll do create cursor keys. So now what we can do is we can go ahead and add an update method that we'll go ahead and call from whichever scene that we add this component to, and then we'll go ahead and check for our cursor keys. So then what we'll go ahead and do is now we're going to go ahead and set our up, down, left, and right properties based on if our cursor keys are being pressed down. So what I'm going to do is I'm going to copy all this from our reset. We're going to go ahead and paste that inside our update. And then what we'll do is jump over to our game scene. I'm just going to go ahead and copy this where we check for our up key is down. We're going to go ahead and paste that here. So then what we can do for each of these, we can just go ahead and paste, and we'll update it to use the appropriate key. So we'll have down, we're going to have left. Let's go ahead and do right. And now we'll go ahead and do space for our space key. All right, so the one last thing we're gonna go ahead and do before we test our component is we're gonna go ahead and add a feature for allowing us to lock our input. So then that way we don't do anything when our component is locked. And so one example of this is after our ship is destroyed, we wanna go ahead and have the animation play for the ship being destroyed and wait a second or two before we spawn our ship. And when that happens, we don't actually need to handle input on our game object because we wanna reuse that same game object. And so we'll go ahead and prevent input from moving our game object around. Let's go ahead and do this. We're going to add a property to keep track of this. And so we're just going to do input locked. So what we'll do is first we'll go ahead and add a default value. So in our constructor, we're going to do input locked. We're going to go ahead and do false. Let's go ahead and add a setter. So we can go ahead and update this value. So we'll say lock input. And then for our argument, we'll expect a value. And then we'll go ahead and do this. Our input is locked. And we're going to set it equal to the value that's provided. Then in our update method, we're just going to go ahead and check to see if this is set to true. And so if we lock our input, we can go ahead and just return early. And then what we'll do is we'll go ahead and call our reset method on our parent class. So then that way we can go ahead and reset everything back to false so we don't handle any input. All right, so real quick before we test our code, what we're going to do is we're going to jump over to our component diagram. And so what we did is the first thing we did is we created our input component. And our goal for this component was we want this just to be a generic class that is going to be extended in other classes that's going to have the core functionality we need for input. And so for our game, this is really the up, down, left, and right keys. So we can tell if a player is moving around in our game or an enemy, and we want to know if they're actually trying to shoot their weapon. And so that is the point of this class here. Is we just have that abstraction. So then that way, whatever type of implementation is built using this as the base class, it'll have its own functionality for figuring that out. And then so next what we did is we created our keyboard input component. And because we extend that input component, we now have these properties here to go ahead and set. And now we can have our own implementation of how we figure that out. And so we decided to go ahead and use our Phaser 3 cursor keys to go ahead and handle input in our Phaser game. And so by using that, we can go ahead and set those values based on our keyboard events. And then what we'll be able to do later on is once we work on our enemies, we can go ahead and create new components for those that'll have its own AI logic for figuring out what input should be happening for that enemy. All right, so now we have our components. What I'm gonna go ahead and do is jump back to our game scene. I'm gonna go ahead and remove our update logic that we have here. Go ahead and remove our cursor keys, and let's go ahead and remove our property. And then we'll go ahead and jump over to our player class, and this is where we'll go ahead and create our component instance, and we'll add it to our game object. And so the first thing we're gonna go ahead and do is let's go ahead and add that as a property in our class, keep track of our components. We'll do keyboard input component. And then what we'll do is after we create our phaser game objects, let's go ahead and create our components. We'll do this. Our keyboard input component is going to be equal to a new instance of our keyboard input component. And so for this, we need our phaser scene. So we'll go ahead and do this.scene to grab the scene from our phaser game object. All right, so the next thing we need to do is now we need to go ahead and add the ability to go ahead and call our update method in our component. And so what we're going to go ahead and do is let's go ahead and add an update method to our player class. And for our update method, we're going to go ahead and expect our timestamp and our delta time from our phaser update game loop. And what we need to do now is we need to invoke this method. And so one way we could do this is in our game scene, we could add back in our update method and then manually call our player.update method here and run that logic. But as our game gets more complex and we add in more game objects, this becomes very tedious if we need to do this for each of our game objects. Another approach, what we could do is we could go ahead and listen for our Phaser 3 scene events, and we can go ahead and listen for our scene update event. And when that happens, we can keep that logic inside this class here and have that invoke our update method. And so this will be really nice if we do this for each of our components, because then they're responsible for listening for when we need to run our update logic and for cleaning it up once our game object is destroyed. And so this is actually really easy to do because each of our Phaser 3 game objects has the event emitter built into it. So now we can go ahead and listen to events. And so this is going to be really easy to do because on our phaser scene, we have an event emitter that we can listen for events for. And likewise, we also have this on our game object, so we can listen for when our game object is destroyed. And so to make this happen, what we can do is we can reference our scene that our game object has been added to. We can then reference our event emitter, and then we can use the on method to go ahead and register an event listener for a particular event. And the event we're looking for will be our phaser. We want our scenes, and then we want our events, and then the update event. And so then what this is going to allow us to do is now provide a function that we want to run every time this event fires. And I'm just going to go ahead and reference our update method here. And then we'll go ahead and pass in this for this context. So then that way we have the right context of when we're running this for our player instance. So because we're creating an event listener, we eventually need to clean this up from our game. And so to do this, we're going to go ahead and listen for when our Phaser 3 game object is destroyed. And to do that, we can go ahead and use our event emitter that's built into our game object. And we can use the once method, so we only fire this one. We only have this event listener fire one time. And the event we're looking for will be our phaser, our game objects, our events, and we want the destroy event. And so anytime the phaser scene is going to clean up our game objects, or if we manually destroy them, this event will be triggered for that game object. And now we can go ahead and have logic run that's tied to this. And so what we're going to go ahead and do is go ahead and add in our own function. We need to go ahead and pass in this for our context. So we have the context of our player. And now what we want to go ahead and do is now we want to go ahead and turn off that event listener that we registered here. And so to do that, we'll copy that line of code. Instead of using the on method, we just go ahead and use off, and that's going to go ahead and turn that off. So now we'll stop reacting to that event. All right, so then what we should be able to do now is if we go ahead and do a console log inside our update, let's log our timestamp and our delta time. And so when our scene refreshes, we'll see right away we get a bunch of logs starting to jump into our console. So what's happening here is in our game scene, every time our update lifecycle event fires, so each tick of our game loop, we're going to go ahead and invoke our update method inside our player class here. And that's because we registered this event listener for that scene event. And so now what we can do inside our update method is now we can go ahead and reference our keyboard input component, and we can go ahead and call our update method to go ahead and run that logic. And so now what we should be able to do is if I go ahead and do console log, if we reference our keyboard input component after we do our update, let's go ahead and check to see if one of our keys is being pressed. And so what we'll do is we're going to do down is down. As we'll start seeing this, let's remove this console log for our timestamp. And so we'll see now, if we go ahead and press our down key, we should see that true is being logged. We can see our logic is actually working how we expect. All right, so now we've seen that our input is working how we expect. The next thing we're gonna go ahead and do is now we're gonna start adding in our components to actually do something with that input. And so what we're gonna do is we're gonna focus on our movement components, and we're gonna focus on our horizontal component for our player. So one thing that's gonna be different between our input and our movement components is we're not gonna have a base class that these components will extend. Instead, these will be their individual components that have their own logic. And so to go ahead and do this, let's go ahead and jump over to our code. Let's go ahead and make a new subfolder under components. I'm just going to call this movement. And let's go ahead and add a new file. We'll go ahead and call this horizontal movement component .js. And so let's go ahead and export our class. We'll export class, and we'll have horizontal movement component. And so now for our horizontal movement component, what we are going to want to do is we're going to need a reference to our input component. So then that way we can check to see if our left or right keys are being pressed. And if they are, then we're going to go ahead and move our Phaser 3 game object around in our scene. And so in order to do this, we're going to need to know about our input component, and we'll need to know about our Phaser game object that we want to go ahead and move around. So what we'll do is we'll add two properties to keep track of this. So the first one, we're just going to go ahead and do game object to keep it generic. So that way we can reuse it with containers and sprites and different things like that. And our second one is going to be our input component. And so for our input component, we'll also keep this generic because we don't care if it's a keyboard input component or one of our bot ones. We just want the base input component. So then that way we can check for our properties and then move our game object accordingly. So now what we can do is let's add our constructor, and then we'll go ahead and add our arguments. So we're going to need a game object, and we'll also need our input component. So then what we'll do is let's go ahead and set those properties. So we'll leave this game object will be equal to the game object. This input component will be equal to our input component. All right, so what we need to do in our component is we're going to go ahead and rely on our Phaser physics to actually go ahead and move our physics game object around our scene. And so to do that, we're going to go ahead and have to update some of the properties on our physics body that will allow us to go ahead and move our game object. And so to go ahead and do this, let's go ahead and add in our update method. And what we'll want to do is we're going to want to check to see if our input is being pressed. And if so, we're going to go ahead and update our game object's velocity to go ahead and start moving in one of our directions. And so what we'll go ahead and do is we'll use if, we'll do our input component, and we'll go ahead and check if left is down. And so if left is down, we want to go ahead and update our game object's X property to be negative. So we start moving it this way across our screen. If it's the right keys pressed, then we want to go ahead and increment it. So we start moving this way. And so to go ahead and do that, we're going to go ahead and reference our game object. We're going to go ahead and grab our physics body from it. And then we're going to go ahead and set our velocity. And so for our velocity, there's a few different ways we can set this, but what we'll want to do is we're going to want to reference our X property. And now we want to go ahead and modify that value, and we're going to decrement it by some type of value. And so for this, we're going to go ahead and let's just go ahead and we'll hard code 20 for the time being. Is just go ahead and start modifying this. Otherwise, what we want to do is we want to check to see if our right key is pressed. So we're just going to go ahead and copy this. Let's go ahead and paste it. And we're just going to do right is down. And if the right key is pressed, then we want to go ahead and increment this. We can bump up that velocity. So we'll go ahead and increment it by 20. Finally, what we want to do is if neither of these are pressed for our horizontal component, we want to go ahead and reset this back to 0. And so go ahead and reset that. What we can do is we can reference our physics game object, our body, and then we're going to go ahead and call set angular acceleration. We're going to go ahead and set to 0. And so that's going to go ahead and reset all of our acceleration that's being calculated based on this velocity here. And so what we're going to do is let's jump back to our player component. Let's go ahead and create an instance of our components. We can do some testing. So what we'll do is let's add a new property. So after our keyboard input component, let's go ahead and add in our horizontal movement component. Then what we'll do is let's go ahead and create an instance. So after our keyboard input, we'll do this. We'll do our horizontal movement component will be equal to a new horizontal movement component. We'll go ahead and pass in this for our game object. And then we want to go ahead and pass in our keyboard input component. All right, so before we can actually test, there's a few things we need to do. One of them is in our update method. We need to go ahead and call our update on our component. And then what we need to do is now we need to go ahead and actually enable our game object, our container, to be enabled for physics. So typically for your physics game objects, what we would want to do, like if it was a sprite, we would use our physics plugin on our scene. and then we'd reference what type of game object we want to add. And so we use the add, and then like if I want to go ahead and create a sprite, I would do this. And what this is going to do under the hood is Phaser's automatically going to go ahead and create a physics body for that game object. And by default, our containers do not have this. And we need to manually create one and attach it to our game object if we want to go ahead and use physics on our container. And so to go ahead and do this, right after we add our game object to our scene, we just need to go ahead and do this. We reference our scene. We'll go ahead and reference our physics plugin. Now we want to go ahead and use the add method. We want to do add existing. We want to pass in our game object. So now what's going to happen is our scene is going to refresh, and we're going to see our ship appearing, and we're also going to see this purple bounding box. And so what this purple box is, this is the body representing our container. And so when we initially set up our game configuration, one of the things we did was we went ahead and set debug to true, and that's why this box is being rendered out. If we set this back to false, we'll see we no longer see our physics body, and we can't use it for debugging. And so we're just going to go ahead and leave that for true for the time being, but that's what that is. And so now that we can see our physics body, now we need to go ahead and modify it so then that way it's actually in the position over our ship and it's more scaled down to actually fit around our ship. And so to do this, we'll go ahead and reference the body now on our container. And the first thing we're going to do is we're going to call set size, and this is going to allow us to modify the overall size of it. And so we're going to do 24 by 24. So now it's shrunk down, looks much better. And now we need to go ahead and modify its position. And so our body is being placed in the origin of our container here. We actually want to be taking up the whole container. We'll go ahead and do this. Let's reference our body again. We're going to do set offset. And now we're just going to go ahead and modify this to be half of our other values. We'll do -12. And now we can see our body's actually over our ship. All right, so go ahead and save. We should now be able to test our changes. So if we tap one of our keys, we'll see our ship starts moving in the direction we press. However, we'll see as we hold our key, our ship keeps speeding up, and eventually it's so fast, it's really hard to control. And so we can see our logic's working, but we're going to want to put some constraints in place so that we can control how fast our ship can actually go. And we'll want to put some logic in place so our ship can't actually leave our scene. And so to go ahead and address this, what we'll do is in our player class, let's go ahead and reference, update our body on our container. And we're going to go ahead and set collide world bounds. We'll go ahead and set that to true. And so what that's going to do now is our ship won't actually be able to leave our scene, and so we'll keep it constrained within our view here. One last thing we're going to go ahead and do is let's go ahead and set the depth for our game object, and we're going to go ahead and set the depth of 2. And so what this is going to do is anytime we render out one of our game objects, Phaser will typically place those game objects in the order that we add them to our scene, but we can control that rendering process by setting a depth on our game objects. And so an object with a higher depth will always be rendered on top of other game objects. And so this will be nice later when we start adding in things like projectiles or our enemies. We'll have our ship always appear on top of them. Or even once we add our background, it would also appear on top of that. All right, so back to our horizontal movement component. What we'll want to do is we're going to go ahead and add some type of cap on how fast our ship can actually go. Because when we press and hold our left or right key, all we're doing is we're just constantly updating our velocity and we're constantly updating it. And so there's no upper bounds for how fast we'll be able to go. And so go ahead and set this bounds. What we can do is we can use the set max velocity property on our game object's body to go ahead and control that. So what we'll go ahead and do is in our constructor, we're going to have reference our game object's body. And so we'll go ahead and do game object, reference body. Let's do set max velocity. And so for our max velocity, let's go ahead and set this to 200. So when our scene refreshes, we'll see now when we hold our key, our ship does speed up, but eventually reaches our max threshold, and we're no longer able to go faster than that value. So this is much better control over our ship. However, when we let go of our key, our ship just keeps flying in the other direction. And so what we'll want to do is we're going to want to add some drag to our game object. And what that's going to do is once we stop providing input, our ship will eventually start slowing down and start deaccelerating. And so this would simulate that there's another force pushing against it, and so that we start slowing it down. And so this is just going to give us a little more finer control over our ship as we're playing our game. And so we'll go ahead and do that. What we're going to go ahead and do is we'll do this. We'll reference our game object. Let's grab our body. First thing we're going to do is we're going to set damping to be true. And then we're going to go ahead and do this, our game object, our body, and we'll do set drag. And we'll go ahead and set this equal to 0.01. So we'll come back to these in 1 second. So now if we test our scene, we'll see as soon as we let go of our key, our ship starts moving, it starts decelerating really fast. And so this gives us a really nice control over our ship as we're playing our game. All right, so what we did here is the first thing we did is we set damping to be true on our physics body. And what set damping does is it allows us to control how drag is applied to our physics body. And basically, what the drag is, this is going to control how our physics body will start to accelerate once there's no longer any movement detected on our game object. And so our object will start slowing down as there's no force being applied to it. And so the drag controls that deceleration. And what damping does, it controls how that's being applied. And so when it's set to true, we're going to go ahead and use a damping effect rather than a linear approach. And so by default, it's set to false. And so we'll literally have apply the same amount repeatedly until our game object stops moving. And by setting it equal to false, what we can then do is we can control how fast our ship will start stopping. And so it's going to be between a value between 0 and 1. And so the closer this value is to 0, the faster ship's going to go ahead and stop. And so what this means is like when we use a value of 0.01, the body will keep only 1% of its velocity per second and it'll start decelerating really quickly. And so the higher this value gets, we'll go ahead and it's going to go ahead and keep up its velocity and only lose part of it. And so just an example, like if I bump this up to 0.5, now what's going to happen is our ship's going to keep moving and it takes a lot longer for it to eventually stop once there's no longer any input. Versus if I put this back to 0.1, now our body is only going to keep 1% of its initial velocity, is going to lose the rest of it until it eventually stops. And that's why we get this really nice quick break effect here. So as an example, if I comment this out, what will happen now if I set damping back to be false, we'll see now it takes a lot longer for us to eventually stop and our game object to actually slow down. All right, so the last thing we're going to go ahead and do for our component is we're also going to go ahead and add a reset method here. So we can go ahead and reset our velocity back to 0 if we need to. So we'll go ahead and do reset. What we'll do is let's go ahead and set our x velocity to 0. So let's copy this. We'll go ahead and paste that here. And we're just going to go ahead and change this to be set to 0. And then we'll also go ahead and reset our angular velocity back to 0. All right, so one last thing we're going to do is we're going to go ahead and move some more values to a configuration file, and we're also going to make some of them configurable for our component. And then that way, depending on which type of ship we're adding this component to, we can control our velocity and different things like that. So what we'll go ahead and do is let's make a new property. We're going to go ahead and call this velocity. And then what we'll do is on our constructor, let's go ahead and add this new argument. And we'll do velocity. And let's go ahead and do this. We'll do our velocity will equal to our velocity. So then what we'll do is down in our update method, instead of referencing our 20, we're just going to do this and we'll reference velocity. So control that when we create our component. Then what we'll do is let's jump back to our player class. And when we create our component, let's go ahead and pass that value in. So we'll have our keyboard input component and we'll go ahead and pass in 20. Let's go ahead and save. And now what we'll do is under our source folder, let's go ahead and add a new file. And we're just going to call this config.js. All right, so now we'll do in our configs, we're going to create variables for each of those values. So we'll do export const. Let's go ahead and do player. We're going to go ahead and do movement, horizontal, velocity. We're going to set that equal to our 20. Then we'll do export const. Let's do component, and we'll do our movement, horizontal, and we'll do drag. We'll set that equal to 0.1. Let's go ahead and copy that, and we'll go ahead and paste it. And now we're just going to go ahead and do for our max velocity. And so we'll have our horizontal component. We'll do max velocity, and we'll set that equal to 200. So now what we can do is back in our horizontal movement component, we'll go ahead and import our config. As we come to the top of our class. Let's do import star as config from, and we'll do our config.js. And then what we'll do is let's go ahead and grab those values. So for our drag, we'll do our config, and we'll go ahead and grab our drag config, and we'll do our horizontal max velocity. Then we'll go ahead and do the same thing over in our player class. So what we'll do is let's go ahead and import our config for one level up. And so when we create our horizontal movement component, go ahead and do our config, and let's do our player movement velocity. So now if we go ahead and save, we should be able to test our changes, and we should see our ship is still moving how we expect it to. All right, so now that we have our core logic in place for our player game object, we're gonna go ahead and switch to focusing on our enemies. And so what we're gonna go ahead and do is we're gonna focus on one of our enemy types. And once we have that logic in place, we'll go ahead and extend that and have a new enemy type. We'll see how we can easily add new enemies to our game. And so for our enemies, what we'll do is we're gonna focus on adding in our base class where we create our phaser game objects. So our various sprites that make up our enemy as well as their animations. And then we're going to go ahead and start adding in some of the components that we built for our player, and we're going to go ahead and reuse them here. And so what we're going to go ahead and do is we'll focus on our first enemy. We'll go ahead and have that enemy just move down our screen. We'll have another enemy type that's going to go ahead and move back and forth across our screen. And so go ahead and get started on this. What we'll go ahead and do is let's show over to our source code, and we're going to go ahead and add a new class for our enemy. So what we'll do is under our objects folder, let's make a new folder, and we're just going to call this enemies. And so for our first enemy, let's add a new file, and we're going to go ahead and call this scout enemy .js. And so let's go ahead and export our new class, new export class. We're going to call this scout enemy. And what we're going to do is we're going to go ahead and extend our phaser game objects, and we'll go ahead and create a container. And so very similar to our player, we're going to have multiple sprites that make up our game object. And by placing them all inside our container, we'll be able to easily move them around our scene. And so what we'll do is let's go ahead and open up our player class, and we're going to go ahead and copy some of our logic here to get us started. So what we'll do is let's go ahead and actually copy all of our code from our class. Let's jump over to our scout enemy, and we'll go ahead and remove anything we don't need. And so for our enemy, we're going to have our ship sprite, and we'll also have our engine sprite, but we won't have a thruster animation, so we'll go ahead and get rid of that. It's going to be built into our engine sprite. Then what we'll go ahead and do is let's go ahead and we'll go ahead and remove our horizontal movement component for the time being. For positioning our game object, what we're going to go ahead and do is we're going to expect an X and Y value. And so we'll go ahead and remove this logic here. We'll have an X and Y argument provided to our super method, and then we'll go ahead and add our game object to our scene. We do want to enable physics for our containers. We can move it around. But then for these enemies, we don't care if they actually collide with our world bounds. They can fly outside it. That'll be fine. And then we'll go ahead and get rid of our depth. So now we actually need to go ahead and start updating our sprites. And so for our sprite, instead of our ship, we're going to go ahead and use our scout texture. We'll go ahead and use the first frame. So we'll do index 0. And now for our engine, we want to go ahead and reference scout and then engine. And then let's go and get rid of our thruster. And we can go ahead and remove that from our container as well. And then let's go ahead and get rid of our horizontal movement component. We'll also go ahead and remove that from our update method. Oh, and then we'll need to go ahead and import our keyboard input component. So I'm going to go ahead and grab that from our player class. We'll go ahead and import that top of our scar enemy. And we are one folder deep, so we just need to add that. We'll go ahead and save. All right, so to go ahead and create an instance of our enemy, let's jump over to our game scene. And so what we'll go ahead and do is we're going to go ahead and add a brand new enemy. And so we're just going to make a new variable. We'll do const. We'll go ahead and do enemy. And we'll go ahead and set that equal to our scout enemy. And we'll go ahead and pass in this scene. And then for our positioning, let's go ahead and reference our scale manager. We'll go ahead and grab our width. We'll divide it by 2, so we'll center it. We'll go ahead and set it at position 0, so we're at the top of our screen. So now when our scene refreshes, we should see our enemy game object positioned at the top. And I'm actually going to go ahead and bump this down a little bit so we can actually see it. And we can actually see our game object in our scene. So one thing we want to go ahead and do is we actually want to reverse the direction of our ship because it's actually facing upwards. And we want the ship to actually fly down towards our player. So what we'll do is on our ship engine sprite, we're going to go ahead and use this set flip Y method. And what that's going to do is going to allow us to flip the game object on the Y axis. So we're going to set this equal to true. And so by default, it's false. And basically uses the origin of that game object to go ahead and reflect it in the other direction. And so now that we've done that, we can actually see our ship is pointing downwards. All right, then next what we'll do is let's go ahead and add in our animation for our ship engine. So what we'll go ahead and do is we'll do in reference our ship engine sprite. We'll go ahead and do the play method. And what we want to go ahead and do is we're going to go ahead and play an animation that has the same name as our asset. So go ahead and save. We should see our engine is now animated behind our enemy ship. All right, so now we have our game object shown in our scene. What we want to go ahead and do is have our enemy automatically move down our screen towards our player. And so go ahead and do that. We're going to go ahead and create a new component for this. And this is going to be our vertical movement component. And it's going to be very similar to a horizontal component. So what we'll do is let's jump into our components folder. Let's go into movement. I'm going to go ahead and copy our horizontal movement component and paste it. And we'll go ahead and rename it. So we're just going to call this vertical movement component. Get rid of copy. And now let's go ahead and update our class name. And so we'll go ahead and have this be vertical movement component. So now for our vertical movement, what we want to do is instead of modifying our X velocity, we want to go ahead and modify the Y velocity on our game object and then apply the same logic that we did before. And so what we'll do is in our reset method, let's go ahead and change this to Y. We'll do the same thing down here in our update method. So we'll increment and decrement our Y velocity. And then what we want to do is update the keys tied to our input. And so when we have our Y be decremented, we want to go ahead and do down is down. And we'll go ahead and do up is down for the other direction. So then for our configuration, what we'll do is let's go ahead and add new config properties for these. We'll use the same values though. And so what I'm gonna go ahead and do is I'm gonna go ahead and break this up. So we'll have our player, we'll have our component configurations here. So we just copy that. We'll go ahead and change this to vertical drag. And then we'll do vertical max velocity. And we'll go ahead and save. So let's go back to our vertical movement component. We'll go ahead and update our reference. We'll have our component movement. We'll have our vertical drag. We'll have our component movement vertical max velocity. And we'll go ahead and save. So now for testing, what we're going to go ahead and do is let's jump over to our player class. And we're going to go ahead and add an instance of this component just so we can actually test and have it move around our scene. So what I'm going to do is I'm going to copy this here. We'll go ahead and paste it. Let's go ahead and change this to vertical movement component. And what we'll do is we'll add a new property to our class. Let's copy this. Let's go ahead and paste it. Let's do our vertical movement component. We'll update our reference. And we'll go ahead and we'll keep the same velocity here. And now it's going to go ahead and call our update method here. So we'll do our vertical movement component. So now when our scene refreshes, if we press the up or down key, we'll see our ship actually moves in the opposite direction. And so what we'll need to do is let's come back to our vertical movement component. And what we'll want to do is we want to reverse this. So if we're moving down, our Y value is increasing. So we want to change that. And if we're pressing up, our Y value is decrementing. And so we'll go ahead and save. So now if we hold the up key, we'll see our ship moves up our screen, and likewise if we press down, it moves down our screen. All right, so now we've validated that our logic works for our component. Now we want to go ahead and add that to our enemy. But for our enemy, we'll need to go ahead and create a new input component that we can pass to our vertical movement component. Basically, for our enemies, we don't want them to be controlled by our keyboard. Instead, we want them to automatically move. And to go ahead and do this, what we'll do is we'll go ahead and create new components that are specific to each of our enemy types. And so what we'll do is let's go into our components folder under input. Let's go ahead and create a new component for our scout enemy. And so what we'll do is we're just going to call this bot. We'll do scout, and we will do input component.js. And so what we'll do is let's just do export class. We'll do our bot scout input component. We're going to go ahead and extend our input component. We'll fix our import to have .js. And now what we'll want to do is let's go ahead and add in our constructor. We'll go ahead and call super. And now all we want to do for our class is we want our enemy always to be moving down. And so what it's going to simulate is if it was our keyboard, our player would just be holding the down button the whole time, and our game object would constantly be moving down our scene. And so to do that, because we have our input component, we can just go ahead and set that property directly on our class. And so we can go ahead and set this. We'll go ahead and do down. We'll go ahead and set equal to true. And then that way our enemy is always moving in the downwards direction. So now what we should be able to do is back in our enemy class. Let's go ahead and jump back over to our scout enemy. Now we want to go ahead and create an instance of our input component instead of our keyboard input component. So what we'll go ahead and do is let's remove that import, and we'll go ahead and change this to our scout, our bot scout input component. We don't need to go ahead and pass our scene for a reference. And let's go ahead and update our reference here. So we're just going to change this to be input component. Now it's a little more generic, and we'll go ahead and set it equal to that. And then what we'll do is we'll just go ahead and do this input component. And so what we'll do is go ahead and save. Let's jump back over to our bot scout input component. Let's go ahead and add our update method. We'll go ahead and just have it do nothing for the time being. So then next what we'll want to do is now we need to actually go ahead and create an instance of our vertical movement component. So on our class, let's go ahead and add that in. So we'll do vertical movement component. We'll go ahead and create our instance after our input component. So we'll have our vertical movement component will be equal to our new vertical movement component. We'll pass in this for our container as our game object. For our input component, we'll go ahead and do this, our input component. And now we need our velocity. So what we'll do is let's jump over to our config file real quick. Let's copy this and we'll go ahead and create a new variable for our enemy. So after our player, let's go ahead and paste this. And so we're just going to change this to be enemy. And then we'll go ahead and do scout movement horizontal velocity. And we'll go ahead and we'll go ahead and change this to be vertical velocity. And we're going to change this to be 10, so it's a little bit slower. Now if we come back to our scout enemy class, let's go ahead and add that in. And so let's go ahead and add in our config. So we'll go ahead and copy that from our player. All right, we need to go ahead and add one more level because we're one level deeper in our folder. And now we should be able to reference our config. And what we'll do is we'll do our enemy scout movement vertical velocity. So finally, last thing we need to do is in our update method, we just need to go ahead and call our component. So we'll do this, our vertical movement component. We'll call update. All right, so go ahead and save. We'll see right away our enemy now starts moving towards us automatically in our game. All right, so what we did here is we created a brand new class to represent our scout enemy, which is one of our two enemy types we'll be creating. And so for this enemy, we want to have a very basic AI where it's going to go ahead and move across our screen automatically for us. And so to do that, we're reusing our components that we've already built. And we're also extending some of the functionality so it can be handled automatically. And so what we did is for our enemy, instead of using our keyboard input component, we created this new enemy component that's specific to our enemy. And so this is our very simple AI where the enemy just moves and comes at us in the game. And so later on, this could be extended with additional functionality. So then that way it can move in different patterns. It could fire different weapons at us. It could be faster, it could be more aggressive, and different things like that. We then create a new movement component and we attach it to our enemies. So that way our enemy will always move towards our player, towards the bottom of our screen. And besides that, most of the other logic is very similar to our player class, where we create our phaser container, we add in our sprite game objects, and then we have the same update logic for updating our enemy to have it come towards us. All right, so now that we have our first enemy built, we're going to go ahead and build our second enemy type, and that's going to be this fighter enemy type. And so for our fighter enemies, they're going to move a lot faster down the screen at us. And then once we add support for weapons, they're actually going to go ahead and shoot the weapons at us automatically. And so to go ahead and create this enemy type, let's add a new file in our enemies folder. We're just going to call this fighter enemy.js. Let's copy all the logic from our scout enemy into our fighter enemy class. We'll go ahead and update our class name. So we'll have fighter enemy. And now we want to go ahead and update our assets we're using for our game. And so for our fighter, we're just going to replace scout with fighter. We'll have our fighter engine. And then same thing for our animation. And then what we'll do is let's go ahead and add a new property for our fighter. So if we're going to go into our config, let's copy this. We'll go ahead and paste it. And so instead of our scout, we'll go ahead and have our fighter. And so for our fighter type, we want it to be a little bit faster than our scout. So we're going to go ahead and bump up our velocity to be 12. And then we'll go ahead and update our reference in our class. And so we'll have our enemy, we'll have our fighter movement vertical velocity. So now with just those few changes, we now have a brand new enemy type. So if we jump over to our game scene, what we should be able to do is I'm going to copy this. We're going to go ahead and paste it. And so I'm just going to comment this one out and we're going to change this to fighter enemy. And I'm going to go ahead and change this to 0. I'll do the same thing as this other enemy now that they're moving. As we'll see right away, now a new enemy type actually spawns in our game. And so now we have this new ship. And we can see that ship actually moves a lot faster towards us. And so with just those few changes, we now have a brand new enemy type in our game. So now we have the basis for two enemy types, our fighter and our scout. What we're going to go ahead and do is we're going to go ahead and update our scout game object to actually have a horizontal movement component. And so for our scout enemy, what it's going to go ahead and do is going to go ahead and fly at us in like a wave pattern, kind of like this, towards our player. And so for that, it'll have an additional component versus our fighter one. We'll have a weapon component once we get there. So go ahead and make this happen. What we're going to go ahead and do is let's go ahead and add back in our scout enemy type. We'll comment out our fighter one for the time being. We'll jump back to our scout enemy. And now what we want to go ahead and do is we need to go ahead and add in our horizontal movement component. So if we jump over to our player class, what we'll go ahead and do is let's remove our logic for the vertical component. Now we've tested it, we don't need that. And what we'll go ahead and do is let's copy our logic for our horizontal movement components. Let's copy this here. We'll add that as a property. We'll come down here. Let's go ahead and where we create our instance, let's copy this. Go to our scout enemy. Go ahead and paste it. Go into our player class. Let's go ahead and copy our import. And then we'll go ahead and remove our import from our player class. And then we'll go ahead and update our reference for our input component. And let's go ahead and update our configuration. And so for our config, for our scout, we'll also need a horizontal velocity. So I'm just going to copy this. We'll go ahead and paste it. And so instead of player, we're going to go ahead and do enemy scout. And for our velocity, we're going to go ahead and do 9. So it's much slower moving left and right. We'll go ahead and save. Come back to our class and let's go ahead and update our reference. And so now we have our enemy scout and we'll have our horizontal velocity. And now we want to go ahead and just call our update method on our component. We'll go ahead and save and we'll see right away our enemy's spawning and it's moving towards us, but nothing's changed. And that makes sense because when we created our scout input component here, all we're doing is we're just having the enemy move down towards us. And so what we'll want to go ahead and do is we'll want to modify this to go ahead and have our enemy move left and right in our pattern. So real quick, before we do that, we need to actually update our fighter enemy class to have its own input component. So what we'll go ahead and do is let's copy our bot scout input component. We'll go ahead and rename this to be bot fighter, and we'll get rid of copy. And so what we'll do is we'll have bot fighter input component. We'll set this as down to be true. We're also going to set down this shoot will also be true. And so this won't do anything for now, but once we do add support for our weapons, it's going to allow the enemy to shoot at our player. So with our new component, let's jump back over to our fighter enemy class, and we'll go ahead and update our reference. So we're not going to use our scout input. Instead, we want to go ahead and use our fighter. So let's go ahead and update our import. So we'll have bot fighter input component.js, and we'll go ahead and save. And just to make sure everything's working, if we jump over to game scene, let's add back in that enemy real quick, and we'll just make sure the enemy spawns and it still comes at us. All right, so now let's jump back to our bot, our scout input component. All right, so for having our enemy move in our wave pattern, what we'll want to do is we're going to have the enemy's input alternate between the left and right key being pressed to have it move back and forth. And so what we can do is if we go ahead and set this dot left is down and we set that equal to true in our constructor, what's going to happen is our enemy's going to spawn and start moving in this diagonal direction because it's moving to the left and down at the same time. And so what we need to do is after the enemy moves so far, we need to go ahead and alternate our direction in the other direction, so that way it moves the other way. All right, so to go ahead and do this, what we need to do is we need to calculate how far we're going to allow our enemy to move in a specific direction before it alternates to the other direction. And so to do that, we're going to go ahead and take our game object spawn point, so it's X position, and then have a value to know how far our enemy can come over in one direction before we bump it the other way. And so with those values, we'll be able to figure out how far the enemy can actually move on our x-axis before we switch directions. And so to keep track of all these values, we'll need to add a few properties to our class. And so the first one is we're going to want to go ahead and store a reference to our game object. So then that way we can get the X value of where our game object is currently at. And then in our update method, we can check that value to see if we're still within that threshold of how far we can actually move. Next, we'll need to keep a reference to the original position where our game object spawned. And so then that way our object will always stay within the range of where they initially spawned at. And so what we'll do is we'll make a new property, and we're going to call this start X. And then finally, we want to have that property keep track of how far that window is of how far they can move. And so what we'll do is we'll call this max X movement. And then now in our constructor, what we need to do is we need to expect our game object as an argument. So let's go ahead and add that in. Then after our super call, we're going to go ahead and do this. We'll do our game object will be equal to our game object. Then our start X position will be equal to our game object's X position when we create an instance of our component. Then finally, for our max X movement, what we're going to go ahead and do is we'll store a property on our config to keep track of this. And so we'll just do config, we'll do our enemy, scout, and we'll call this movement max X. So now what we'll do is let's go ahead and jump over to our fighter enemy. Let's copy our config import here. We'll go and paste it. Let's jump over to our config and we'll come to our scout enemy. Let's go ahead and add that in. So we'll do an export const, and for our max movement, we're going to go ahead and set that to 40. And so what that's going to do is going to give our ship a range of 80 pixels. And basically we're going to go ahead and move 40 in one direction and then 40 in the other direction to create that wave pattern. So now if we jump back to our input component, what we're going to do is we'll have our enemy start moving in the right direction when it spawns. So we're going to go ahead and set left to be false. And then what we'll do is we're going to do this. We'll do right. We're going to set that equal to true. And now in our update method, we need to check our game object's position and figure out if we need to switch directions. And so what we'll do is we're going to go ahead and take our game object's current X position. We're going to check to see if it's greater than our original starting position plus our max movement. And so if our game object is further than this point here, as an example, we want to go ahead and have our game object start moving to the left. Otherwise, we want to go ahead and check our X position if it's less than like this threshold here. We want to go ahead and reverse the direction. And so we'll go ahead and use our game object's current position. We're going to compare it to the original X position of where it spawned. And we'll go ahead and add in that max movement value that we just added. And so once we reach past that window, we just need to reverse our directions. And so we'll just go ahead and paste this here. Copy this, we'll go ahead and paste that. And so we'll want to go ahead and set left to be true. So we start moving in the other direction and right to be false. Otherwise, now we need to go ahead and check the opposite of that. So let's go ahead and copy this here. And so we'll do else if. And so if our X value is less than our start X minus our max movement, then we want to go ahead and set left to be false and right to be true. All right, so with our changes, what we need to do now is now we need to come into our scout enemy class, and we create an instance of our component. We need to go ahead and pass in our game objects we have as a reference. All right, so we're going to save and refresh. We'll see right away our enemy spawns and it starts moving in the pattern that we want it to. Very nice. And so if we want to go ahead and tweak this, what we can go ahead and do is back in our config, we can go ahead and modify our max value of how far we want our enemy to move. And so what we could do is we could change this to be like 80. And so that's going to be a bigger pattern. So we'll see our enemy now moves in a bigger wave. Or if we want it to be a much smaller, we can go ahead and do something like 20. And now it's going to be in a much faster wave pattern like this when it comes towards our player. And so by tweaking this value here, we can easily create a different configuration for our enemy. And we could also pass this in as part of our constructor, or we could actually add it as a setter that we could do on our component. So there's a bunch of different ways we could modify that to change the behavior. But for now, I'm going to go ahead and reset that back to 40. All right, so now we have our two basic enemy types, and we gave them a simple movement pattern to allow them to come down our screen at our player. The next thing we're going to do is we're going to work on adding weapons to our game. And so for our weapons, we're going to create a very basic weapon component. And what we're going to end up doing is we're going to attach it to our player and to one of our enemy classes. And then that way our enemies will be a little bit different besides just their movement pattern. And so for our weapon component, what we're going to end up doing is we're going to create an object pool within Phaser by using a group. And what this is going to allow us to do is we're going to be able to reuse our game objects that we're creating for our bullets. And then that way we're not wasting resources by continuously creating new game objects and then destroying them. And so by putting our configuration into this component, what we're going to be able to do is for our player and our enemy, we'll be able to control how frequently they can fire, what the limit of number of bullets they can do is, and different things like that. And that's going to in that way makes each ship type feel a little bit unique. And then later on, this could be extended. So then that way we could have an advanced weapon. So maybe a boss enemy could have a stronger weapon, or maybe the player could get an upgrade and so they have a better weapon than the enemy. And so to go ahead and start creating our weapon component, what we'll do is in our source folder under components, let's go ahead and add a new folder, and we're going to call this weapons. And then what we'll do is let's add a new file, and we're going to call this weapon component .js. All right, so the first thing we do is let's go ahead and export out our class. We'll do export class. Let's do weapon component. And then we'll go ahead and add in our constructor. All right, so for our weapon component, for it to actually work, what we're going to do is we're going to end up associating this with one of our other game objects in our Phaser 3 game. And so for our player and our enemy ships, this is where we'll be attaching our weapon. And so to do this, we'll need to pass in the game object that's associated with this component. So then that way, when we create our Phaser group, we can put it in the same scene as that other game object. And so we're going to go ahead and add a property to keep track of that game object. Besides that, we're also going to need our input component. And so in order to know if we're supposed to fire our bullets or not, we'll need to go ahead and check our input component if that shoot button is being held down. So then we'll also need to keep track of our Phaser group that we create. So we're going to go ahead and call this bullet group. And then finally for our group, one of the things I mentioned was we'll be able to configure how frequently we can actually fire our bullets and limit the number of bullets based on which game object this component's attached to. And so to keep track of all that, we'll go ahead and add another property. We're going to call this bullet config. So then what we'll do in our constructor is when we create an instance of our component, we'll expect our game object. We're going to expect that input component, and then we'll also expect our bullet config. So then what we can do is let's go ahead and assign those to our properties. So we'll have our game object will be equal to game object. Our input component will be equal to our input component. And then our bullet config will be equal to the bullet config. And so now to go ahead and actually create our group, what we're going to end up doing is we're going to be using a Phaser 3 physics group. So then that way we can create physics sprites in our game. And then that way they're going to go ahead and have our physics. So we'll have our body. So we'll be able to check for collisions. And so this is very similar to creating a regular group. So what we'll do is let's go ahead and assign this to our property. And so we'll have our bullet group. And we're going to set it equal to this. We're going to reference our game object. Then we want to grab our Phaser scene. And now what we want to do is reference our physics plugin. And now we want to use the add property to go ahead and create our game objects. So then what we'll want to do is we'll want to go ahead and create a group. So now for our group, we can go ahead and provide our configuration for our group. So when we go ahead and create a Phaser 3 group, there's a few different things we can pass. One of them is if we have any existing game objects we want to add to our group, we can add them when we create our group. We can also pass configuration options that will be applied to all of the child game objects. And so if we want to select a certain gravity to each game object or an acceleration, by passing that here, we can do that. In addition to that, we can also provide configuration options for the group at the top level. And so one example is if I want to go ahead and provide a name to our group, so we know which group this is, we can do that here. And so what I'm going to do is we're going to go ahead and create a unique name for this weapon component. And I'm just going to call this bullets. And then we want to go ahead and we're going to use a GUID, a unique identifier, so then that way each instance of our weapon component will have a different name. And so to go ahead and do that, we're going to go ahead and use Phaser, and so we'll do phaser.math.random.rnd, and then UUID. And what that's going to do is generate that unique identifier, and then that way each of our weapon component groups will have a unique name. And so Phaser doesn't override this, but allows us to set it. So if we want to go ahead and reference our groups by that identifier, we can. And then one other property we're going to set is enable. And what this is going to do is typically we can go ahead and enable our group right out of the gate when it's created. But we can go ahead and set this to false. And what this is going to do is it won't actually be enabled until we need to use those game objects. And so we'll go ahead and set that to false because we won't actually want to do anything with our bullets until the player actually fires a bullet or the enemy does. And so what this is going to do, this is just going to create our Phaser 3 physics group, but we're not going to have any other game objects associated with it. And so to actually create our bullet game objects, so our sprites, there's a few ways we can do this. One of the ways is we can try to grab a game object from our group, and if there's none that's available, we can create a new one on the fly. Another option is we can use built-in methods to go ahead and create multiple game objects, so that way our pool has a starting number of objects to reuse. And so that's what we're going to do, because we know with our player, we'll be firing lots of bullets, same thing with the enemy, and so we'll just have a pool of bullets ready to use, and so we don't have to worry about creating them on the fly. So to go ahead and do this, what we're going to do is we're going to reference our bullet group, and then we're going to use the create multiple method. And so what this method does, it allows us to provide a configuration for configuring the game objects that will be created. And so the first thing we're going to set is the key. And so our key is going to be our asset key for which texture will we apply to these sprite game objects. And so we'll use our bullet sprite. Next, we can go ahead and specify quantity. And so this allows us to specify how many of these game objects we want to create so they're available in our pool. And so for this, we're going to pull this from our bullet configurations. We've not defined this yet, but one of the properties we're going to end up setting is going to be a max count. And this will allow us to configure a total number of bullets that'll be available for each weapon component instance. Then we're going to go ahead and specify our active and our visible properties, and we're going to set both of these to false. And so what these do is when our game object is not active, Phaser's not going to apply any physics to this game object since it's not actually in use. And when it's not visible, it won't be rendered out to our scene. And so now what this does is this now adds 10 sprite game objects to our group. So then that way we can now use them when we're ready to. All right, and so before we can actually test and see if anything is in our group, we actually need to create an instance of our component. So what we'll do is let's jump over to our player class, and we're gonna go ahead and create our weapon component. So the first thing we're gonna go ahead and do is I'm gonna go ahead and add a property for this. And so let's come up to the top of our class. We'll go ahead and add in weapon component. Then what we'll do is after we create our components in our constructor, we're gonna go ahead and create our weapon component. So what we'll do is we'll do this. Let's do our weapon component. And let's actually fix our name. So we'll have component with a small, let's go ahead and fix our name real quick. So we'll have weapon component. And now we're gonna set it equal to a new weapon component instance. And so for this, we'll go ahead and pass in this for our container will be our game object that we're associating with our weapon component. Then we'll go ahead and pass in our keyboard input component. And so we can check for if our space key is pressed. And then finally, we need to provide our configuration. And so right now for our configuration, the only thing we're expecting is this max count here. So that's all we'll pass for the time being. So for max count, what we'll do is we'll go ahead and we'll specify this in our config like we did with our other properties. So we're going to go ahead and do config, and we'll go ahead and do player, we'll do bullet, and we're going to go ahead and do max count. I'm going to copy that. Let's jump over to config, and we'll go ahead and add that in. So under our player, we'll go ahead and set that in. So we'll do export const. And so for our starting bullet, and so for our max number of bullets, we'll go ahead and do 10. So now if we go ahead and save, let's come back to our weapon component, and I'm gonna go ahead and do a console log. So I'm gonna do console log, and I'm gonna log out our bullet group. All right, so when a scene refreshes, we should now see a console log from our weapon component file. And if we go ahead and expand that, we'll see this is a reference to our Phaser 3 group. And then what we'll see for our children, we have 10 objects in there, and these are all going to be sprites that have been added to our scene. And then so if we take a look up in our top left corner, we'll see that we had some game objects created in our default position of 0, 0. And right now, because they're not active, they're not being rendered, but we can, because of debug, see where their physics bodies are. All right, so now we've seen that our game objects are in our group. What we need to do now is we need to add support for once we do hit the spacebar or our input component recognizes that we are able to shoot, we're going to go ahead and fire one of our bullets. And so to go ahead and do that, we're going to have that check in our update method. Let's go ahead and add an update. And so what we need to do is we're going to go ahead and check our input component to see if we're holding down the shoot button. So it'll be our spacebar for our player. So we'll do if this, our input component, and we'll do shoot is down. So if that's true, what we need to do is now we need to grab one of our objects from our group, and then that way we can go ahead and fire that bullet from where our player's ship is. All right, so if we are holding down our shoot button, what we need to do now we need to grab one of our game objects from our group, and we'll want to go ahead and update its position to be in front of whichever ship is actually firing our bullet. And so to go ahead and grab a reference to our game object, what we can do is we can use one of our built-in methods on our group. And so what we're going to do is we're going to do const, we're going to do bullet, we're going to set equal to this, our bullet group, and then we're going to do get first dead. And so what this method does is it iterates through our array of children for our group, and it's going to find the first object that is active is set to false. And if it's set to false, it's going to go ahead and return that game object, so then that way we can reuse it. And what will happen is if all of our children are currently active, it's going to go ahead and return null. And so this method is really useful if we don't want to create a new game object when none of our game objects are actually available in our pool. And so for our weapon, we want to control the max number of bullets our player can actually shoot at a time. And this method is going to allow us to do that. If we didn't care, we could use a different method that would allow us to go ahead and create a game object if one's not found. But we won't be doing that. And so what we need to do now is we need to check to see if our bullet was actually found. So what we're going to do is if our bullet is undefined, Or if our bullet is equal to null, then we want to go ahead and just return because there's nothing else we can do with the button being held down. If a bullet was found in our group, now we want to go ahead and update its position. So what we're going to go ahead and do is we're going to calculate that. So we'll do const x will be equal to our game object. So for our player, it's going to be our container for our ship. And we'll go ahead and just copy the same x value. Next, we're going to go ahead and do our y value. So do const y. So we're also going to grab our game object, and we'll grab our y property. But now we're going to add an offset. So then that way our bullet will be in front of our ship instead of at the same position. And so we'll go ahead and do add. And so for this is going to be different depending on which game object that the component's tied to. So we're going to grab this from our bullet configuration, and we'll do our y offset. So then real quick, let's jump over to our player class. We're going to go ahead and add that in. So we'll go ahead and grab our y offset. We'll go ahead and pass that in, and we're just going to do -20 for our player. So then back over here, now what we want to do is now for our bullet object, we want to go ahead and update our game object's position. And so to go ahead and do that, we're going to go ahead and do our bullet. We're going to do set position, and we're going to go ahead and do X and Y. So after we've done that, now what we need to do with our bullet is we need to go ahead and make it active, and we want to make it visible. And so to go ahead and do that, we could go ahead and set our active and visible properties on our game object. Another option, what we can do is, because we also want to enable our physics body, is we can go ahead and change this method here to be enable body. And what this method allows us to do is we can pass multiple arguments to go ahead and set all these values at one time. And so what we're going to go ahead and do is first we're going to go ahead and pass true. And what that will do is it's going to go ahead and reset the position on our physics body for our bullet. So right now our bodies are up here in the top left hand corner. And so when we spawn our bullets, we want that body to be where we actually position our game object instead of up here where it's originally at. So by setting that to true, it'll be updated. And then we pass our X and Y properties of where we want that game object to spawn. And now we can go ahead and specify those properties for enabling and for showing our game object. So we'll want to go ahead and set these to true for both of these. So if we want to go ahead and test real quick, let's jump over to our player class. And what we'll want to do is in our update method here, let's go ahead and call our update method on our weapon component. So now what will happen is if we press our spacebar, we'll see right away this bullet is added to our scene and is placed right in front of our ship. And because of our existing logic, what's happening is we're going to have multiple key presses. So we're adding multiple game objects at one time. And that's why it only looks like we can only add one bullet at a time. So as an example, if I hold the left key and then hold down space, you'll see now we spawn all of our bullets. And so what's happening here is our update method, because this is tied to our game loop, this is being called multiple times per second. And so as we're holding down that key, this is being invoked many, many, many times. And because those game objects are available, it grabs one and then it goes ahead and spawns it. And then after we spawn our game objects, they're now active and visible. So now we don't have any more available in our pool. And so for us to go ahead and space out how frequently we spawn these bullets, we're going to need to add some type of interval, which will prevent us from firing our bullets this rapidly. And so to go ahead and do that, what we want to do is when we fire a bullet, we're going to want to go ahead and keep track of when that bullet was actually fired. And then once we fire it, we want to go ahead and do a countdown. And once we're reached 0, then we'll be eligible to go ahead and fire a bullet again. And so to go ahead and keep track of this, what we're going to do is let's add a new property to our class. And so what we'll do is we're going to call this fire bullet interval. And what we'll do is in our constructor, we're going to go ahead and set this to be 0. So as soon as we create our component, we'll say we're at 0. So we're eligible to go ahead and spawn one of our bullets. And then what we'll do is down here in our update method, we're going to go ahead and check to see before we even do this logic here, if our interval is greater than 0. So if our fire bullet interval is greater than 0, that means we're not eligible to fire a new bullet. So we're just going to go ahead and return early. So now what we want to do is after we fire our bullet, we want to go ahead and update this to some value. So what we'll do is we'll do our fire bullet interval, and we're going to pull this from our bullet config. And so for our bullet config, we're going to add an interval property to this. And so what this is going to do is now it's going to change that 0 to some millisecond value that we want to keep track of. And so let's say we want to spawn a bullet every 2 seconds, we'd set this to 2000. And then what we would need to do in our update method is before we do this logic, we actually need to decrement this interval based on our delta time in our game. And so for our delta time, to go ahead and track this is actually built into Phaser. And so when our update method is called for our scenes, we receive two arguments. The first one's going to be the current time of when this was invoked. And then the second one's going to be our delta time, which is the number of milliseconds since the last frame was ran in our game. So basically the amount of time that's lapsed between the last call. And so with that delta time, what we can go ahead and do is use that to decrement an interval, because we'll know how many milliseconds has passed since the last time this ran. And so for us to go ahead and actually get our delta time on our weapon component, what we need to do is we'll add as an argument, we'll jump back to our player class, and now what we need to do is we need to pass that delta time to our component. And so what we'll go ahead and do is now, before any of our other checks, we're just going to go ahead and do our fire interval, and we'll go ahead and we're going to decrement it by that delta time. So now what I'm going to go ahead and do real quick is I'm just going to do a console log, and we're going to go ahead and log our delta time, and then we'll log our fire bullet interval. And so what should happen is immediately we should start logging a bunch of information, and you'll see we have our delta times, and now our interval is now growing very fast in the negative direction. And because it's below 0, we should be able to fire one of our bullets. All right, and then so what we'll need to do in order to fully test this, you'll see once we hit our spacebar, we get nan, and that's because we didn't specify our interval here. So we're trying to pass in undefined. So what we need to do is back in our player class, let's go ahead and pass in that interval. And so we'll go ahead and add a new property, and we're also going to set this in our configuration. And so what we'll do is we're going to change this to player bullet, and we'll do interval. We'll go ahead and copy that, jump over to config. We'll go ahead and do export our const. We'll do our new variable, and let's go ahead and do 300 for our milliseconds. Go ahead and save. So now you'll see now if we hold our spacebar and move, now we have that gap between our bullets because we're waiting that 300 seconds before we can actually fire our next bullet. So now that we've addressed the issue with spawning our bullets, what we actually need to do now is actually add in our logic to have them actually fly across our screen towards our enemies. And so to do that, we just need to go ahead and update our velocity on our bullets, so then that way they fly in the direction we want. So right after we call enable body, what we're going to go ahead and do is we'll update our body's velocity. And so we're going to go ahead and reference our bullet. Let's do body. We're going to do velocity. And what we'll do is we're going to target our Y velocity. And we're going to go ahead and decrement this by this, our bullet config. And we'll go ahead and add a speed property. And then what we'll do is let's jump over to our player class. We'll go ahead and define the rest of our properties real quick. So besides our interval, we'll need speed. And so we'll go ahead and leave that blank for a second. We're also going to need a lifespan. And we'll come back to this in a second as well. And then we'll have our max count, our offset, and then one last property is going to be flip Y. We're going to set that equal to false. So then what I'm going to do is I'm going to copy this here, and we'll go ahead and update our names for our properties. And so we'll have our bullet, and we're going to have speed, and then we'll have bullet, and we'll have our lifespan. So in our configuration, we'll go ahead and do export, or const, we'll have our speed. For our speed, we're going to go ahead and do 300. And then we're going to have our lifespan, and we'll go ahead, export const. And for our lifespan, we're going to do 3. I'm going to save. And so for our configuration, what we're doing here is our speed is tied to our velocity that we're adding here. And so if we hit our spacebar, we'll see now our velocities applied to our game objects, and now they fly forward through our scene. Our other properties we added was lifespan. All right, so lifespan, what that's going to be used for is as we fire our bullets, at some point, we need them to actually become inactive in our game. And so this is either going to be when it collides with an enemy game object, or once it's reached the end of our scene or has been alive for a number of seconds, we want to go ahead and have it be disabled so we can reuse it in our object pool. If not, what's going to happen is we're eventually going to run out of bullets because we don't actually kill any of them off, and so we don't have any available in our group. And so by using our lifespan, we'll say they're alive for so many seconds, then we'll go ahead and have them disappear when they're off our screen, and our player can reuse them. Our last property, flip Y, that's going to be tied to when we spawn our game objects. So right now when we spawn them, they're faced towards the enemy game object, but when our enemy spawns them, we'll want them to be facing the other way, and so we want to go ahead and flip it like what we did with our enemy ships. All right, so for our lifespan, what we're going to need to do for each of our bullets is we're going to need to keep track of how long that bullet's been alive for. And so what we can do is when our bullet is spawned, we can go ahead and set a property to the lifespan value that we set. And then as our delta time is being passed to us, we can go ahead and decrement it just like we're doing our fire bullet interval here. And then once that property is reached 0, then we can go ahead and disable our game objects. We'll be able to reuse it. And so one of the ways to do this is we can use the setState method. And what this method does is allows us to provide a state to a game object that can be a number or a string. And Phaser internally will never modify this property, and we can actually use it for our game. And so to go ahead and do this, what we're going to go ahead and do is right after we set our velocity, we'll go ahead and use that method. So we'll do bullet. We'll go ahead and do set state, and then what we'll do is we'll do our bullet config. We'll grab our lifespan, and then so for decrementing it, what we're going to want to do is we'll need to decrement this for each of our child game objects in our group. All right, so actually we'll go ahead and update our state and decrement our lifespan. We'll need to go ahead and update our game object to go ahead and listen for the Arcade Physics World step event. And what this event does is anytime our Physics World instance is updated, there's a single step in our update game loop, then this event will be emitted. And what's really nice about this will be emitted after our physics bodies and our colliders have already been updated. So already after our update method is ran, then what we can do is now check to see if our lifespan is now below 0, and we can decrement our value based on the delta time that's provided there. And so by using this event, we're going to have this very nice game loop where basically we'll update our physics body, and so we'll update our X and Y position of our bullets. And then after that's updated, we're going to go ahead and check to see how long it's been alive for since it spawned, and then we'll go ahead and despawn it. And so again, listen for this event. What we're going to do is we're going to do logic very similar to like what we did for our player, where we listen for our scene events this way. So what we're going to do is copy this logic here. We'll come back to our weapon components. Let's go up to our constructor. We're going to go ahead and paste that code. And so what we're going to go ahead and do is for these events, we'll need to go ahead and reference our game objects. We'll do this. We're going to go ahead and reference our game object. Let's copy that. We're going to go ahead and paste that for each of these. And then so for the event we want to listen for, it's going to be Phaser. It's going to be physics. That's going to be our arcade physics, our events, and then our world step. And so for this, instead of calling update, we want to go ahead and call world step. And so we'll add this method in a second. And then when our game object is destroyed, we'll also want to go ahead and turn this off, just like what we did in our player class. And so what we'll do is let's copy our event name. We'll go ahead and paste that. And we'll also update our method name. We'll go ahead and paste that. So now what we'll do is below our update method, let's go ahead and add in world step. And we'll go ahead and add in one argument. And we're just going to call this delta. And so for our delta, now what we need to do is for our Phaser physics group, we need to grab all of our children and then update their state based on that delta. And so to grab all of our children, we're going to reference our bullet group. We're going to use the getChildren method, and this is going to return an array of all of our game objects. And now with that array, we can iterate over it. And so we'll go ahead and have our bullet. And for each bullet, what we'll want to do is first we're going to check to see if it's active. So if our bullet is not active, then we don't need to do any of this logic, so we can just go ahead and return early. Otherwise, what we want to go ahead and do is now we want to update that state. And so what we'll do is we'll do our bullet, we'll reference our state, and we're going to go ahead and decrement it by the delta that was provided to this method. So now, because now we're decrementing that value provided, 3, by this value, now we need to check to see if it reaches 0 or below, and if it does, now we want to go ahead and disable it. And so we'll add an if statement, so we'll do if our bullet state is less than or equal to 0, then what we want to go ahead and do is we're going to call a disable body. And so what this method does, it's very similar to our enable body, where we can set multiple things at one time. And what it does is allows us to make our game object inactive. And so if we pass true for that, it also let us make it not visible. And we go ahead and pass true. And so now what's going to do, it's going to hide our game object and make it not active. And then internally, our Phaser group will make it available to our pool, so we'll be able to reuse that object. All right, so if we come over to our scene, we should be able to go ahead and test. If we hold down our space bar, we'll see we're firing all of our bullets based on our interval. Oh, and then we eventually run out. So what happened? Let's take a look at our constructor. Yes, so when we register our event listener, we didn't register our event listener correctly. So for our game object, because we're listening for this physics event, we don't want to do this on our scene event directly. We want to go ahead and do our scene. Then we want to reference physics, and we want to go ahead and reference the physics world. So let's copy that, and we'll go ahead and replace events with that. And now we should be able to go ahead and test. So now if we fire our bullets, we'll see eventually we start to run out. And because now our lifespan is now reaching 0, we're now getting our object back into our pool. and we're able to fire that bullet again. All right, so now that we have our object pool working properly, we're just gonna make a few more updates to our bullet game object, and then we'll be done with our component. And so as we're firing our bullets, the first thing that I notice is that our body for our bullets is quite large compared to our bullet. And so once we add in our collisions, that's not really a fair collision because that collision box is much bigger than our game object. And so what we're gonna go ahead and do is we're gonna go ahead and resize it to match our game object. But in addition to that, our bullets are kind of large, especially when compared to our enemy game object ships. The bullets look bigger. So we're gonna go ahead and scale these down so that way they're a little bit smaller. So what we're gonna go ahead and do is right after we call set state, let's go ahead and modify these. We're gonna go ahead and do our bullet. First, let's go ahead and set our scale. And so for our scale, we're going to just scale this down to 0.8. And now we want to go ahead and update our bullet's body size. And so we'll do bullet. We're going to reference our physics body. Let's call set size. And we're going to go ahead and do 14 by 18 pixels. And then the last thing we're going to go ahead and do is we're going to go ahead and set our flip Y property. And we're going to set that to use our bullet config property that we passed in earlier. And so we'll do bullet, set flip Y. And this will be equal to this, our bullet config, and then our flip Y property. So now if we go ahead and save, we'll see our bullets are much smaller and our physics bodies actually match our game objects, so it'll be a little bit more fair. The last thing I'm going to go ahead and do is we have an animation for our bullet while it's flying, and we're going to go ahead and play that. So right after we do our set state, let's go ahead and reference our bullet game object. We'll do play since it's a sprite, and we'll go ahead and we'll play our bullet animation. So now when we play, we'll see our bullet looks like it's shiny. It's actually rotating. So real quick, what I'm going to do is I'm going to bump this up to 2, and just so it's a little bit bigger, so a little bit easier to see. You see we have this really very nice bullet animation, and it's going to look really nice once we get rid of our debug. So it's going to revert our scale back down. All right, so one last thing we're going to do for our component is we're just going to add a getter so we can actually reference our phaser group. So what we'll do is after our constructor, we're going to go ahead and add get, and we're just going to add get bullet group. And then what we'll do is we'll return this and we'll reference our bullet group. All right, so with our weapon component in a good spot, what we're going to go ahead and do is now we're going to go ahead and update our enemy to actually have a weapon as well, so they can go ahead and fire at us. And so the first thing we'll do is let's go ahead and jump over to our configuration. Let's copy all of our bullet properties here for our player. We're going to add those for our enemy. And so what we'll do is we'll come down to our enemy fighter. Let's go ahead and add in these properties, and then we'll just copy this. We'll do enemy fighter, and we'll change player to be enemy fighter. So now because this is all config driven, we can actually modify these properties. And so for our speed, what we're going to go ahead and do is we're going to do negative 200. And so because our bullets are going to be flying at us this way, we actually want our velocity to be negative, so that way it moves down our screen. Next, for our interval, we're going to go ahead and we're going to make this larger, so that way our enemy starts off firing really slow, and so it'll be an easier enemy when the game starts. Then we'll keep our lifespan and our max count the same. So now what we should be able to do is let's jump over to our fighter enemy class, and let's go ahead and add in our component. So what we'll do is after our input component, let's go ahead and add a property. We'll do weapon component. We'll come down here. Let's go ahead and create an instance of our weapon component, and we'll set equal to new weapon component. And then what I'm going to go ahead and do is we'll go ahead and provide our configuration. And so for our weapon component, we're going to go ahead and pass in this. For our container, we'll pass in our bots input components. We'll do this input component. And now for our configuration, I'm just going to jump over to our player class. And I'm going to go ahead and copy this here. We're going to go ahead and paste it. But now we'll go ahead and update our properties. And so we'll have enemy fighter, and we'll have our bullet speed. We'll just update all these. And now for our offset, well, we're going to go ahead and change this to 10 so it matches our game object. And then finally for flip Y, we're going to set this to true so our bullet flies in the correct direction. So now what we should be able to do is let's jump over to our game scene. And we're going to go ahead and uncomment out our fighter enemy. And I'm going to comment out our scout enemy so we can go ahead and do our testing. So now when our enemy spawns and starts flying towards us, oh, nothing happens. Yeah, so back in our fighter enemy, I forgot to call our update method. So let's go ahead and reference our weapon component, and we're going to call update. Oh, and one last thing we need to do is let's go ahead and pass in our delta time. So if we go ahead and save and refresh, we should now see our enemy starts flying towards us, and he's slowly firing bullets at us. All right, so one last change we're going to go ahead and do is let's jump over to our config, and we're just going to go ahead and bump up our bullet speed to be negative 280, so that way the bullets actually fire a little bit faster at the player. So now that we have our weapon component, the next thing we're going to do is we're going to work on adding collisions to our game. And so what we're going to go ahead and do is we're going to add collision checks between our player ship and our enemy ship. So then that way when they collide, they'll be destroyed. Likewise for our weapons, so our player's bullet group and our enemy ships, and our enemy's bullet group and our player ship, we're going to check for collisions between those as well. And so to do this in Phaser, there's a few different ways we can check for collisions. And when we're using physics, two of the common ways are we can use a collider or we can add an overlap. And so what a collider is, when we have our two physics bodies, so as an example, our player ship, our physics body here, and our player ship's physics body, as soon as they start touching, if we had a collider, we'd start applying force to them and they would actually collide together. And so this is really good for like when our player's moving around, we don't want them to move through a wall or through the floor, versus the other way is we can check for an overlap. And how that works is we will take our ship's physics body and then check for an overlap. So between these two purple boxes, and if there's any overlap at all, we'll be notified. And so for our game, we'll be using overlaps because we don't actually need to apply any type of force to our two game objects. But we just want to know as soon as they overlap, so then we actually react to that. And so to go ahead and do this, let's jump over to our game scene. And what we're going to do is we're going to add a few colliders just to see how everything works. And then we're going to go ahead and refactor this to use some of our components. And so to go ahead and use an overlap, what we need to do is we need to reference our Phaser scene. We're going to go ahead and reference our physics plugin. And now we're going to go ahead and use the add method for our factory. And we're going to add what's an overlap. And so now for our overlap, there's a few different things we can provide here. We can provide a single game object that has the arcade physics body. We could add an array of game objects, and we can even add a group. And so there's multiple ways we can check for overlaps between one and many game objects in our game. And so to start, we're going to go ahead and check for our overlap between our player ship and our enemy ship. And so what we need to do is we need to provide our two arguments here. And so we're going to go ahead and provide our player, and then we're going to go ahead and provide our enemy. So once we do this, now we can go ahead and provide a callback, so we'll be notified as soon as there's any overlap between these two physics bodies. And so we'll go ahead and provide our callback here. And so in our callback, we're actually being notified of the two game objects where our overlap is actually happening. And so this is useful when we're checking for our overlap between one and many, so like between our players' bullet group and a particular enemy group, because then we'll know exactly which two game objects are actually overlapping. And so for this, what we're going to be notified of is we're going to get our player's game object. So when we do our overlap, our callback is going to provide our arguments in the order we specify here. And so because we have our player ship and then our enemy ship, when we get notified of this collision, it's going to be our player and then our enemy game object as well. So then what we can do in our callback now, and then I'm just going to go ahead and add a console log, and I'm just going to say collided with enemy. So if we go ahead and refresh our scene, what we should see now is our enemy ship should appear. And as soon as this physics body starts overlapping with our player ship's physics body, we can see our console log triggered. And so the next thing we're going to go ahead and do is we're going to see how we can add an overlap between our player and the weapon group so we can see how that works. And so let's go ahead and do physics. We'll do add. Let's do an overlap. So now we're going to use our player game object. Now we want to use our enemy's weapon game object. So we're going to go ahead and reference our enemy. And what we need to do is now we need to expose this. So then that way we can actually reference that group. And so to do this, let's go ahead and open up our fighter enemy class. Let's go up to the top below our constructor. And what we're going to go ahead and do is we're going to go ahead and add a getter so we can go ahead and return this. And so we're going to go ahead and return our group and we'll return our component. So let's add a getter. So we'll do weapon, game object, group. And we're going to go ahead and return this, our weapon component. And we're going to go ahead and return our bullet group from this. And then we'll also go ahead and return the component. So we'll make a getter for that. So we'll do our weapon component. And instead of returning our group, we'll just return the weapon component. So now back in our game scene, what we should now do on our enemy class is we should have our getter. So let's go ahead and grab our weapon game object group. And so now we're passing a group of our physics game objects. And so in our callback, we're going to be notified in the same order we specified here as well. So we'll have our player game object, and then we'll have the single bullet that actually collided with our player. And so we're just going to go ahead and call this projectile game object. And then let's go ahead and we're just going to add in a console log. And just so we can verify these objects, let's add in our player game object. Then we'll add in our projectile game object. So now what should happen is when our enemy's bullet actually overlaps with our player, we should see our console log. So if we go ahead and expand this, what we should see is we should see two objects. So we have our player object here, and then we have this other object here, which is a sprite. And so this is our bullet that actually overlapped with our player. So now finally, we're going to go ahead and do the inverse of this. We'll have our enemy, we'll check for a collision with that, and our player's weapon group. So what we're going to need to do is we're going to need to go ahead and expose these getters as well on our player class. So what I'm going to go ahead and do is I'm going to copy both of these. Let's go ahead and open up our player class. And then what we'll do is after our constructor, we'll go ahead and paste those in. Go ahead and save. All right, so now we exposed our property. Let's go ahead and jump back to our game scene. And so what we're going to go ahead and do is we're going to go ahead and flip our order. So we're going to have our enemy, and then we'll have our player weapon game object group. So now we'll have our enemy game object group. We'll have our enemy game object, and then we'll have our projectile game object. So we'll go ahead and update our console log. And just so it's a little bit clear, I'm going to go ahead and comment these out so we can see them. And so the reason we went ahead and switched these arguments here is when we receive our callback for our collision check between a single sprite and a group, one of the things that Phaser always does is it'll always return the single sprite first, then the sprite associated with the game object where the collision happened. So no matter what order we place these in, this is the order we'll always receive these arguments. And so just to make it consistent, by lining it up this way, it can remind us. So as an example, if we go ahead and refresh our scene, if we fire our bullet, we'll see as soon as it overlaps with our enemy, we'll see our fighter enemy, and then we see our sprite for our bullet. And if we go ahead and reverse these, so we'll have our player weapon group first, and then we have our enemy, go ahead and fire our bullet. We'll see as soon as it overlaps, we still receive our fighter enemy game object first, then our bullet. So this is something to keep in mind while you're working with your overlaps when you check between a sprite and a group. Alright, so now we see how our collisions overlap work in our game. What we're going to do next is we're going to go ahead and create two new components. So for our components, we're going to go ahead and focus on our health and our collider components. And so for our ships, when we have a collision, we're going to have this collider component that we're going to go ahead and invoke for our various type of collisions. So like when a bullet hits a ship or if a ship collides with another ship, we're going to do different logic. Our second component is going to be our health component. So instead of just having our ships automatically destroyed when we get hit by a bullet, we're going to add a health component to our ship so we can actually take some damage. And then after so much damage, then our ship would be destroyed. And then this way we'll have some gameplay variety types where if we collide with a ship, it'll just explode. If we collide with a bullet, we'll end up updating our animation to take some damage. So we're going to get started with these components. What we'll do is let's go into our components folder. And we'll go ahead and start with our health component. So let's make a new folder, and we're going to call this health. And then we'll go ahead and make a new file called health component.js. Let's export out our class. So we'll have our health component. We'll add in our constructor. And so for our health component, basically what we need to keep track of is we'll need our maximum life that we can have for our ship, and we'll need our current life. So we're going to go ahead and add some protected properties to our class. And so we'll have our starting life. Then we'll add our current life. And then we'll add one more property to keep track if our ship is actually dead or not. And so we'll do is dead. And so now in our constructor, we'll go ahead and expect our life as our argument. And then we'll go ahead and use that to set our starting life and our current life. So we'll do our starting life is going to be equal to our life. We'll have our current life will be equal to our life. And then finally, we'll go ahead and set is dead to be false when we create our instance of our component. So now what we're going to go ahead and do is we'll add a couple getters so we can get these properties. So we'll get life, and we'll go ahead and return this, our current life. Next, we'll go ahead and add a getter for is dead, and so we'll return this is dead. All right, we're also going to go ahead and add a reset method. And so this is going to be useful for once we start reusing our game objects. It'll allow us to go ahead and reset our stats when we respawn our game object. So for this, we'll go ahead and set our current life back to our starting life. And we'll go ahead and reset is dead back to false. And now we need to go ahead and add in our methods for when there's a collision. And so we're going to add a method called hit. And so this will be for when we hit another game object that's not a ship. So this will be like when our bullet collides with our player ship. So the first thing we're going to do is we're just going to make sure that we're currently not dead. And if we are dead, we're just going to return early. If we are not dead, we want to go ahead and decrement our life. So we'll do this, our current life, we'll do minus equals 1. And now we're going to go ahead and check to see if our health is now at 0. So if our current health is less than or equal to 0, then we want to go ahead and set this is dead. We'll set equal to true. Finally, we're going to go ahead and add one more method for dying. And so this will be for cases where we want our ship to automatically go ahead and explode. So like when our ship hits another enemy ship, or if we ever added any other type of game objects, we could call this method here. So we'll go ahead and set our current life equal to 0, and we'll do this is dead will be true. So now that we have our health component, the next thing we're going to do is we're going to go ahead and build our collider component. So under our components folder, we'll make a new file. And so we'll go ahead and do a collider for our subfolder. And then for our file, we're going to go ahead and do collider component.js. We'll export our class, add in our constructor. And now for this component, we're going to get a reference to the life component that this collider component's attached to. And so what we're going to do is now we'll have our collision check. So when we have that collide with enemy ship, this is where I'll call our life components and update our stats there. And so we'll have our life component. And so for our constructor, we're going to receive this as an argument. And so we'll have our life component. And now what we'll do is let's go ahead and assign that. And now we're going to go ahead and add in our two methods. And so for our game, we're going to have two methods. We'll have collide with enemy ship. And so when this happens, first we're going to go ahead and check to see if we're already dead. So if we are already dead, we won't go ahead and do anything. So we'll do if this life component is dead, let's go ahead and return. All right, and then we're going to go ahead and use our life component, and we're going to go ahead and call our die method. And so for our methods here, we're just adding some safeguards. So because when we add our overlap checks, they're fired multiple times per second, basically for every update of our game loop, our callback's going to be invoked. And so it's happening many times. And so by adding these safeguards here, we're going to only run our logic when we need to. So next, we're going to go ahead and add in a collide with enemy projectile. And so this will be used for when we collide with bullets. And so we're going to go ahead and do the same thing. I'm going to copy this logic here. But instead of calling the die method, we're just going to call the hit method. All right, so with our two new components, we're going to go ahead and add these to our various classes. So we'll go ahead and start with our player class. So at the top of our class, let's go ahead and add in our two new components. So after our horizontal movement, let's go ahead and add health component. And then we'll go ahead and add our collider component. And just so it's a little bit easier, I'm just going to copy these. I'm going to go ahead and paste them to our enemy class as well. So after our vertical movement, let's go ahead and paste those in. And then we'll do the same thing in our scout class. So let's open up scout enemy. After our movement, we'll have our health component and collider component. So now back on our player class, we're going to go ahead and add a getter. So we can go ahead and return our collider component because we'll need to call that from our game scene. So what I'm going to go ahead and do is I'm going to copy this here. We'll go ahead and paste it. And so instead of returning our weapon component, let's go ahead and return our collider component. We'll make our getter to have the same name. I'm going to copy this, and we'll do the same thing in our other classes. So we'll add our getter to our scout enemy, and then also our fighter enemy. And so one other thing we're going to do is let's go ahead and add a getter for our health component. And so we'll have our health component. And we'll copy this, and let's add it to our other classes as well. All right, so the next thing we need to do is we actually need to create instances of our health and our collider components. And so to go ahead and do this, the first thing we're going to do is let's come to our config file. We're going to go ahead and add properties for our player and enemy health, and then now we can reference them in our classes. So we're going to go ahead and do player health, and we're going to go ahead and set this equal to 4. And then for our enemies, we're just going to go ahead and give them a health of 2. So we'll go ahead and do enemy fighter health, and we'll do 2. Copy this. And we'll do enemy scout. So now back in our player class, what we'll do is after we create our weapon component, let's go ahead and do this. We'll do our health component will be equal to a new health component. Then we'll reference our config and we'll do our player health. So that's going to do our collider. So we'll do our collider component be equal to a new collider component. And we'll pass in our health component. And then real quick, let's jump over to our collider class. And what we're going to do is we're just going to rename this to be health component because that's what we're actually using here. All right, so with that change, we'll go ahead and come back to our player class. Let's copy these 2 lines of code. We'll jump over to our scout enemy. We'll go ahead and create our components there as well. And then we'll jump over to our fighter enemy and let's create our components. So let's go ahead and jump back over to player class. We're going to go ahead and update our imports. So let's copy these 2 lines of code. Come to the top of our class. Now let's go ahead and fix our health for our various enemies. And so for our fighter enemy, we're going to have our fighter health. Scout enemy, we're going to go ahead and have our scout enemy health. And for our references, we need to add one more folder. And we'll fix that in fighter enemy. And then we'll go ahead and save. All right, so now with our changes, let's jump back to our game scene. And what we're going to go ahead and do is we're going to go ahead and update this, our overlap, to go ahead and call our new components. So we'll start with our player game object. We'll go ahead and call our collider component, and then we'll do collides with enemy ship. So now what we're going to do is let's copy that, and we'll also do the same thing for our enemy game object. So I'm going to go ahead and save. Our scene should refresh. And now for us to actually do something, what we need to do is in our enemy classes and our player class and our update method, we need to check our health component and see if if we ever die. And then if so, that's what we'll go ahead and hide our game objects. So instead of destroying our game objects, because we're going to try to reuse them, we just want to make them not visible and not active to our game. So what we're going to do is we're going to add a check. So we'll do if our health component is dead in our update method. Then we want to go ahead and do this. We'll do set active, or set equal to false. This set visible. We're going to set that to false as well. So then what we'll do is let's copy this, and we're going to do the same thing over in our player class. So we'll go ahead and jump over to our player class. Let's come down to our update method, and we'll go ahead and paste in our code. So now when our scene refreshes, we should see that when our ships collide, they now disappear from our scene. However, we can still move our game objects around, and we can see that the bodies are still being moved. So what we're going to want to do is we're going to want to add a safeguard where if our game object's not active, then we want to go ahead and stop doing our update logic. So what we'll do is we'll do if we are not active. So basically our ship is in a destroyed state. We don't want to do anything. So now if we go ahead and let's copy this, let's jump over to our fighter enemy class. We'll add the same thing there. Go ahead and save, and let's test one more time. So now when our two game objects collide, we'll see now our physics stops updating and we hide our game objects in our scene. All right, so the next thing we're going to do for our player class is we're going to go ahead and add a logic so that if we actually die, we're going to go ahead and play our animation for having our ship be destroyed. And so to go ahead and do this, we'll need to change some of our logic here. So currently we're hiding our whole container, and we're making our whole container's body not active. And what we actually want to do is we're only going to hide parts, select game objects from our container. And so we're going to want to hide our engine and our thruster, but then we're going to go ahead and have our player ship. We're going to go ahead and have that do our animation for exploding. And so for this to work, what we're going to do is we're going to make a new method to have this logic. So we're going to go ahead and call this hide. And so what we'll do is let's copy our 2 lines of code here for we're setting our container to not be active and to not be visible. And then we want to go ahead and we're going to update our individual game objects to not be visible as well. And so we'll do this. We're going to do our ship engine sprite. We're going to do set visible, and we're going to go ahead and set that equal to false. We're going to go ahead and copy that line of code, and then we're going to do the same thing for our thruster. And so we'll have our ship engine thruster sprite set visible equal to false. And then just as a safeguard, we're going to go ahead and lock our input. And so what we're going to end up doing is we're going to end up adding logic for our lives later on, and so we'll need to make sure we lock our input until our ship respawns. And so we're just going to go ahead and set this equal to true. So now what we're going to do here is let's go ahead and call our new method. And what this is going to have the effect of doing is basically going to hide our enemy's container. And now what we want to do is we want to go ahead and make our container visible because we'll be reusing our hide method later, so we're not going to place it there. And so what we'll do is we'll do this. We're going to set visible, so our container should be visible in our scene. And then we want to go ahead and now play that animation for the explosion. And so we're going to reference our ship sprite, and we're going to go ahead and call play. And we want to go ahead for our key, we want to do explosion. And then we're going to go ahead and return so we don't run the rest of our logic in our update method. So if we go ahead and save, what should happen now is when our player ship collides with our enemy ship, we now have that nice explosion animation. Alright, so with that collision working how we want, now we need to actually do our collision between our ships and our bullets. And so the first thing we're going to go ahead and do is we're going to go ahead and add a new method to our weapon component. So then that way we have a way to make our bullets state inactive when it collides with one of our ships. So what we're going to go ahead and do is let's jump over to our weapon component. We'll come down at the bottom of our class, and what we're going to do is let's add a new method. We're going to call this destroy bullet. We'll receive one of our bullet game objects, and then what we're going to do is we're just going to call set state. And we're going to set this to 0, so then that way it should die. And then our next world step update, we're going to go ahead and disable the body, and it won't be visible. So now back in our game scene, what we want to go ahead and do is now we need to go ahead and grab our collider tied with whichever game object the collision happened. Then we'll call collide with enemy projectile. So what I'm going to do is I'm going to copy this here. Let's get rid of our console log. I'm going to go ahead and paste it. And then we're going to go ahead and do collide with enemy projectile. Let's copy this. We're going to paste it down here. But then this is going to be our enemy game object where we grab our collider component. So the next thing we'll want to do is now we need to grab our weapon component. We need to call that new destroy bullet method. We're going to go ahead and reference the enemy that the weapon game object group is tied to. And so let's go ahead and grab our enemy. We're going to go ahead and grab our weapon component. And now we want to go ahead and call destroy bullet. And now we're going to go ahead and pass in our projectile game object. Let's copy this line of code. We're going to paste it in our other collider as well. But now we want to go ahead and change this to be weapon component, our player's weapon component, and call destroy bullet. So now what should happen is when our enemy's bullets collide with our ship, you'll see our physics body stops updating and our game object is hidden from our scene, and then our player is not destroyed. Because what's happening is we're just now decrementing our health. And so what we can do is let's go ahead and jump over to our config and let's go ahead and bump our player's health down to be 1. Now we'll go ahead and test, and when that bullet hits our ship, we should be destroyed because now our health is at 0. Likewise, if I change this to something like 2, it should take 2 bullets to destroy us. So if we get 1, 2, our ship will explode. Nice. All right, so then what we're going to go ahead and do is let's go ahead and test shooting at our enemy player. We'll see after 2 bullets, our enemy ship disappears from our scene. And so just to make sure everything's working with our scout enemy, let's go ahead and uncomment this out. Go ahead and do that. All right, so before we test our scout enemy, let's go over to our class. Oh, let's go ahead and copy our logic from our update. So let's copy these lines of code here. We'll come into our scout enemy. And so now if our scene refreshes, we should be able to fire our 2 bullets. And if we can hit the enemy, we'll see they disappear from our game. Perfect. All right, so for the last thing we're going to do is when our player ship collides with our enemy's bullets, we're not actually showing any damage on our ship. So what we're going to do is we're going to add logic to update our ship's frame to show we're taking damage. And so to go ahead and do this, what we'll do is we're going to go ahead and jump over to our player class. All right, so what we're going to go ahead and do is in our update method, after we check to see if our ship is dead, what we'll do is if it's not dead, we're going to go ahead and update our frame. So to do this, we'll go ahead and do our ship sprite. We're going to call the set frame method. And then for this, we need to provide the index of the frame that we want to go ahead and set. And so for this, we're going to go on ahead and grab our config. We're going to go ahead and grab our player's health. And then we want to go ahead and subtract our health component's current life. And what that's going to do, that's going to give us how much health that our player has left. And then based on that, we're going to show a different damage frame for our ship. So real quick, if we go into our ship, we'll see here if our player is fully healed, this will be frame 0. So if we have 4 max health, we're at 4 health, we want to use frame 0. Versus if we have 3 damage, we're only going to have 1 health left. And so we want to go ahead and have this frame here. And then what we're going to go ahead and do is we're just going to go ahead and change this to a string. And so we're just going to add, and so we're going to do toString, and then we'll go ahead and save. So now if we jump back to our game scene, let's swap our enemies out so we can use our fighter enemy that'll fire our bullets. All right, so go ahead and save. We should be able to test. So when the enemy's bullet hits our ship, we should see that our ship gets updated. And when it hits it another time, it gets updated one more time. So now that we have our health and our collider components, and we see that our collisions are working between our enemy and our player's ships as well as our projectiles, the next thing we're going to do is we're going to work on our spawning logic for our enemies. And so what we're going to do is we're going to go ahead and create some object pool for our 2 different enemy types. So that we can go ahead and keep respawning our enemies in our game on an interval. And so for this, we're going to be creating some new components in our game. So these ones won't be actually tied to our game objects directly. They're going to be more system level components. And so this is where we're going to go ahead and create our enemy spawner, where we can provide it which type of enemy we want to spawn, as well as some type of configuration for how frequently we want them to go ahead and spawn. And so to go ahead and do this, what we're going to end up doing is we're going to use a phaser group, and we're going to use a lot of the same logic that we did for spawning our bullets. But instead of spawning a bullet game object, we're going to go ahead and spawn our custom class for our enemy. And then just like how we did with our bullets, we're going to go ahead and make our enemies not active. And then that way we can reuse those game objects instead of having to create a new enemy game object every time we want to spawn an enemy in our game. All right, so to get started building our spawner, what we'll do is let's go into our components folder, and we're going to go ahead and add a new subfolder. We're going to call it spawners. And then what we'll do is make a new file. We're going to call it enemy spawner component. So let's go ahead and export out our class. We'll do export class. We'll do enemy spawner component. Let's add in our constructor. And so for our spawning component, what we're going to need is we'll need our phaser scene. We're going to go ahead and create our group to add to our scene. We'll also need our configuration for how frequently we want to go ahead and spawn our enemies. And then we'll need a property to go ahead and keep track of our groups. Let's go ahead and add all these as properties to our class. So first we'll have our phaser scene, then we'll have our spawn interval, and we'll have spawn at. And so spawn interval will be how frequently we're going to go ahead and spawn our enemies, and spawn at is when we'll go ahead and spawn our first enemy after our game starts. Finally, we'll go ahead and have our group. So now what we'll need to do is now we need to add these to our constructor as arguments. So we're going to have our phaser scene. Our next argument is going to be our enemy class. And so for our component, what we want to be able to do is we want to pass the name of the class, either fighter class or a scout enemy class, and pass that here, so then when we spawn our enemy, we have a spawner tied to that particular enemy type. Besides that, we're going to have a spawn configuration, and this is going to have our spawn interval, our spawn at, and other things like that we need for creating our class. So now what we'll go ahead and do is let's go ahead and set up our scene. So we'll do this.scene will be equal to our scene. Next, we want to go ahead and create our group. So we're going to do this, we'll do our group will be equal to a new this scene.add.group. Then we provide our group configuration. So one thing to call out is we're not going to go ahead and use a physics group for this, mainly because when we did our weapon component, we're letting Phaser automatically create our physics sprite for us. And so by using the physics group, Phaser knows to use a physics sprite over a regular sprite. For this group instance, we're going to go ahead and pass our class type through. And so we'll have a custom class of game objects we're creating. And so we don't need a physics group because we're going to rely on our default enemy classes we created. So then what we'll do is we'll add in our name. So similar like what we did for our bullets group, we want to give each spawner a unique name. So instead of bullets, I'm going to go ahead and reference our spawner's name. And so we're just going to go ahead and do this. We're going to reference our constructor. And we'll grab our name property from it, and then we'll have a UID. So next, we need to go ahead and pass in our class type. And so this is what we'll use our enemy class. And so when we pass class type for our property, Phaser is going to use this and then use the new keyword to create an instance of what we pass here. So by passing in that class, we can now let Phaser create new instances of our game object. And so for this to work, we need to go ahead and return one of our Phaser game objects as the type that gets instantiated. And because we're extending our container here, that's why we can pass through our fighter enemy and our scout enemy. So Phaser is going to go ahead and use the new keyword to create a new instance of that container, and then pass us these arguments that we're expecting. Next, we're going to go ahead and add a new property. We're going to do run child update. We're going to set that equal to true. And what this is going to do is for this group, for each game object, Phaser is automatically going to call the update method on that game object. All right, so after we create our group, let's go ahead and set our other properties. So let's go ahead and set up our spawn interval and our spawn at. So this is going to be equal to our spawn config. And we'll go ahead and add a property interval. Then we'll go ahead and do spawn at, and we're going to go ahead and do spawn config, and we're going to go ahead and do spawn at. All right, so now what we want to go ahead and do for our spawner component is now we're going to go ahead and add our event listeners for when our update method is invoked and when our world step method is invoked as well. So what we're going to do is we're going to go ahead and jump over to our fighter enemy class. Let's go ahead and copy this logic here for we listen for our update. We're going to paste that in our enemy spawner component. And then what we're going to end up doing is we're going to end up removing this from our enemy classes since we passed in update is true here. But we'll come back to that. So what we're going to go ahead and do is we need to go ahead and update our references. We're going to have this scene events on. We need to go ahead and add in our update method. So we're going to jump over to update enemy. I'm going to go ahead and copy this here. We're going to go ahead and paste it. Then we have our update. So now we're going to go ahead and change our update here. So instead of this dot once, we're going to go ahead and do this scene events once. Then we'll go ahead and turn off our event that we're listening for. Next, we want to go ahead and do our world step. So what I'm going to do is I'm going to jump over to our weapon component. I'm going to go ahead and copy that line of code here. We're going to go ahead and come back to our enemy spawner. Let's go ahead and paste it. And then we'll go ahead and change our reference. So we're going to have this dot scene, our physics world. Then we'll go ahead and add in our world step. We'll go ahead and jump back to our weapon component. I'm going to copy that method with our arguments. Come back here. We'll go ahead and paste that. And then we need to go ahead and turn that off when our scene is destroyed. And so we'll use the off method. Now we need to update the event we're listening for. It's not tied to our game object. It's actually tied to our scene. So let's go ahead and copy this. We're going to replace that. Instead of update, we want to go ahead and listen for our destroy for our scene. All right, so what we did here is we just added two event listeners, one for our scene update event and one for our physics arcade world step event. And so we'll be using both of these for updating our game objects very similarly to like in our weapon component, when we wanted to go ahead and spawn out new instances of our bullet, we'll be doing the same logic for spawning out instances of our enemies. All right, so the next thing we'll need to do is now in our update method, this is we'll need to go ahead and add in our logic for spawning out our enemies. So what we'll go ahead and do is I'm going to jump over to our weapon component, and we're going to want to use similar logic to how we're spawning our bullets here. And so basically we want to go ahead and check our spawn at time and then decrement our delta time, similar to what we do to our interval here. And then and then if we're greater than 0, we want to go ahead and return. So we're just going to copy these lines of code here. We're going to go ahead and paste it. Let's go ahead and update our references. And so we're going to do spawn at, we'll go ahead and subtract our delta time. And if we are greater than 0, we want to go ahead and return. As soon as we are at 0 or below, now we want to go ahead and spawn an enemy in our game. And so to go ahead and do this, we want to go ahead and grab an enemy from our group. And so we'll do const, we'll do enemy, it's going to be equal to this, our group, and we'll use the get method. And now we need to go ahead and specify our x and y position of where we're going to position our game object. And so I'm just going to use x as a placeholder for now, and we'll do -20 for our y value. So our get method is a little bit different than our get first dead method that we use for our bullet group. And so what get's going to do is it's going to loop through our child game objects and try to find one that's not active. If one's not found, Phaser's going to go ahead and create a brand new instance of the game object that's tied to this group for us and return that new instance. And so for our enemy groups, we're not going to have a max capacity for how many enemies we'll go ahead and spawn. And then that way, we don't ever have to worry about having one of our game objects be dead. We'll reuse them when they're available in our game. So now for our X position, what we want to go ahead and do is we want to spawn our enemy randomly in our scene instead of in a hard-coded position. And so what we'll do is we're going to go ahead and calculate that. So we'll do const X is going to be equal. And so we're going to do a random value. And so for that, we're going to do phaser. We're going to do math, we're going to do random, and now we want to do between. And so this allows us to provide a min value and a max value, and Phaser's going to return a value somewhere in that range. And so for this, we'll do 30, and then we're going to reference our scene. We'll grab our scale, we'll grab our width property, and we'll go ahead and subtract 30 from that. And so that's just going to give us a little bit of leeway for our game, so that way it spawns somewhere within like this frame like this. So then after we spawn our enemy game object, we want to go ahead and update our spawn at property. And so we'll do this.spawn at will be equal to this, our spawn interval. All right, so if we want to start testing some of the logic we added, we need to go ahead and create an instance of our component. So what we'll do is let's come into our game scene, and let's go ahead and comment out our enemy code for the time being, and we'll also comment out our overlap checks. So after we create our player, let's go ahead and create a new spawner. So what we'll do is we're going to go ahead and do const. We'll make a variable do scout spawner. We're going to set that equal to a new enemy spawner component. And now we need to go ahead and provide our scene. So we'll do this. Our enemy class. So let's go ahead and do our scout enemy. And now we need to provide our configuration. So for our configuration, we'll need our interval and we'll need our spawn at properties. And so what we'll do is let's go into our config file and we'll go ahead and add these. So we'll go ahead and copy this kind of code here. We'll do our scout first, and then so we'll have enemy scout, and we'll do group, spawn, interval. And for our interval, we'll go ahead and do 5 seconds. So we'll have 5,000 milliseconds. Let's copy that. Go ahead and paste, and then we'll do our spawn at property. Then we'll go ahead and do spawn start. So this will be when they start spawning in our game, and so we'll do 1 second after the game starts. Let's copy both those. We'll go ahead and paste them onto our fighter. And we'll go ahead and update our name. And so we'll have fighter. And so for our fighter, we'll go ahead and spawn at an interval of 6,000 milliseconds. And we'll start at 3,000 milliseconds. So back in our game scene, all right, then what we'll do is let's go ahead and import our configs. We'll do import star as config from our config.js file. And now for our configuration for our scout, let's add our interval. And then we're going to go ahead and do our config. We'll do our enemy, scout, spawn group interval. And now let's do our spawn at. We'll go ahead and copy this. We'll go ahead and paste it. And now we just want to go ahead and do our spawn start. And so after we save, we should see right away in our game that our enemy starts spawning, and we'll see it starts respawning on a pattern. And so it's going to go ahead and spawn at a different X position, and then it's going to go ahead and come down to our player, and it's going to keep respawning. And so now that we have our enemy group spawning our enemy game objects, what we're going to do next is now we're going to re-enable our collisions, and we're going to update our checks to use our enemy group here. So what we'll do is let's go ahead and uncomment this code here. And for this to work, instead of referencing our enemy, we need to reference our enemy group from our spawner. So let's go into our spawner component. We'll need to add that as a getter. So what we'll do is we'll do get, and we'll do phaser group. We'll go ahead and return this. We'll return our group. So back in our game scene, what we can do now, instead of passing our enemy, we want to go ahead and reference our spawner. So we'll have our scout spawner, and then we want to go ahead and grab our phaser group. And so next, we'll also go ahead and do the same thing for our player's weapon group and our enemy. So let's go ahead and do our scout spawner, and we'll go ahead and do our phaser group. And then real quick, what we're going to do is let's go ahead and comment out our code here. We're checking for our enemy's bullets with our player's ship, and we'll come back to that. All right, so go ahead and test our code. If we go ahead and try destroying our enemy's ship, oh, looks like we have a few bugs. So the first one is after the ship is destroyed, their box collider still hit our player's ship, and we were still destroyed. Then when our enemy respawned, it looks like they never reappeared in our game, but we can see that their box actually disappeared. And so what we need to do is after our ship is destroyed and we go to respawn it, we need to make it reactive. So what we'll need to do is after we respawn our enemy group, we need to actually go ahead and make them active again. So if we go into our scout enemy class, and so what's happening right now is after our ship dies, we go ahead and set it to be not active and to be not visible. And so what this is going to do is it's going to make it eligible to be respawned from our phaser group object. However, because we made it not visible, we need to make it revisible once we spawn that game object. And so if we come back to our enemy spawn component, what we need to do is when we grab a new game object from our group, we need to go ahead and reset some of our properties, like reset its health, and then that way we can respawn a fresh instance of our enemy. And so to go ahead and do that, what we're going to do on our scout enemy class is we're going to add a reset method that's going to go ahead and reset some of our components as well as that state that we need. And then so what we'll do is before our update method, let's go ahead and add in reset. And so inside this method here, we'll want to go ahead and make our game object active and visible again. We'll reset our health component, and we'll go ahead and reset all of our other components as well. All right, so the first thing we'll do is let's go ahead and copy these two lines of code here, and we're going to go ahead and set them to be true. So we'll make our container visible, we'll make our container active, we'll go ahead and make our container visible. Then we want to go ahead and reset our components. So we'll start with our health component. So with our health component, let's call reset to reset our health back to full health. And then we're going to go ahead and reset our vertical and our horizontal movement components. So we'll do this, we'll do our vertical movement component, let's do reset, and then we'll do this, we'll do our horizontal movement component, we'll do reset. All right, then what we'll want to do is back on our enemy spawner components, go ahead and call that new method. So we'll do enemy, we're going to do reset. Now if we go ahead and test our changes, if we go ahead and destroy our scout enemy, our enemy should respawn. However, we have this bug where the enemy is swerving across our scene. So what's happening is on our scout enemy, when we create our input component, we created the start X, and what that does, that determines where our enemy is actually going to move in our scene. And so after we respawn our game object, we're choosing a new X value. And so we need to recalculate that maximum movement for the area our game object can move. And so to go ahead and do this, we'll make a new setter. And so we'll do set, we'll do start X, we'll have our value, and we'll go ahead and do this. Our start X is going to be equal to our value. So now back in our scout enemy, we want to go ahead and set that for our component. So in our reset method, what we'll do is we'll do this, we'll do our input component, we're going to call start, we're going to set start X. We'll set it equal to this.x to grab our X position from our container. So now if we go ahead and test, let's try destroying our enemy ship. It should respawn, and if it's on the other side, we'll see now it's moving over here where it's supposed to. All right, so now we done that with our scout enemy. Let's go ahead and copy this logic here, and we're going to place it over in our fighter enemy. So what we'll do is let's go ahead and add a reset method. We don't need to call our start X, and we don't have a horizontal movement component. Let's go ahead and reset. We don't need to do that. All right, so the next thing we're going to go ahead and do is let's jump back to our game scene, and we're going to create a spawner for our fighter enemy. So we're going to go ahead and copy this logic here. I'm going to go ahead and paste it. I'm going to call this fighter spawner. And then for our class type, we'll have our fighter enemy. And now we're going to go ahead and update our references here. So we'll have our enemy, fighter. We'll have our group spawn interval. We'll go ahead and paste that. We'll do our spawn start. All right, and then what we'll go ahead and do is let's go ahead and add in our overlap for that group. So let's copy this here. We're going to go ahead and paste it. And so we'll have our fighter spawner group. And then let's go ahead and do the same thing for our weapon. Let's copy and paste this. And we'll go ahead and do our fighter spawner phaser group. So now what we should be able to do is back in our scene, we should be able to test. We should see our fighters are now spawning. And we'll see now when our ships collide with them, they are destroyed just like we expect. And then we'll see our enemies are still respawning just like we want them to. So one other thing we need to do is now we need to go ahead and re-enable our overlap check for our enemy's weapon group and our player's ship. And so in order to do this, we're actually going to have to modify our logic for how we're checking for our overlap. And so currently how our code was structured before was after we create our enemy instance, we can reference that game weapon group from that enemy. Now with our new spawner classes, we're not spawning our game objects and creating them until we actually need them from our pool. And so what this means is for each new enemy that spawns, we need to have this collider enabled so we can actually check for collisions between that enemy's weapon group and our player. And in order to do this, we'll need to know when we create a brand new instance of our enemy. And this is actually really easy to do in Phaser. There's actually a property we can pass when we create our group for a callback to be notified when we create a new instance of our game object that we specify here. And so to go ahead and do that, what we'll do is after run child update, we're going to do create callback. And so with this, we can go ahead and provide our callback, and we're going to receive an instance of the enemy that was instantiated. And so we'll have our enemy for an argument, and now in our callback function, now we can do something with it. And so what we're going to want to do in this method is now we want to go ahead and we need a way to notify our game scene that, hey, we have a brand new enemy game object, so now we need to add that collider. And so to go ahead and do that, what we're going to do is we're going to go ahead and create a new component. And so from our initial diagram, this is going to be the events component that we detailed here. And so this component is going to be responsible for sending out events that we want to use in our game. And this will be one of them. Anytime we spawn an enemy, we're going to go ahead and emit an event. And then the other thing we're going to go ahead and do is we're going to add a new method to our enemy classes for init. And that's going to allow us to initialize our game object with any additional things that we need that we can't do inside our constructor. And so when we create our instance of our enemy class here, we're just going to go ahead and create an instance. That means our constructor will run, but if there's anything else we want to go ahead and pass to it, we can't do that, but we can do that here by calling a special init method. And so that's where we'll go ahead and we're going to pass through our event bus component to our enemy. So then that way we can initialize our components that we need, and then we can actually use that event bus to emit our events. And so what we're going to go ahead and do is first for each of our enemy classes, let's go ahead and add that init method, and then we'll come back and we'll add our event component. So what we'll do is we'll do enemy, and we're going to call a new method, and we're going to call it init. So what I'm going to do is I'm going to copy this. We're going to go ahead and come over to our fighter enemy class, and let's go ahead and add that method. And so right above reset, we'll go ahead and add in init. And then what we're going to go ahead and do for the time being is we're going to take all of our component logic where we create all of our components. We're going to move that out of our constructor. And we're going to go ahead and place that down in our init method. So what we're going to do is we're going to copy all this code here. We'll go ahead and paste it down here. And then we'll leave all of our code for creating our game objects and our sprites alone up there. And so what this is going to allow us to do is now we're going to go ahead and create instances of our components. And then we'll emit our event. And what that's going to allow us to do is now that we have our components in place, we can go ahead and register our overlap between our new fighter instance and our weapon group object. Later on, if there's anything else we need to pass, we're going to go ahead and pass it into our init method, and then that way we can instantiate our components with those dependencies. And so we'll need that later for our event bus as well, because some of our components are going to evolve, and we'll need our event bus. So now what I'm going to go ahead and do is I'm just going to copy this real quick and jump over to our scout enemy. We'll go ahead and add that in. And then we'll go ahead and do the same thing. So let's copy our components. We'll take them out of our constructor. We're going to do it inside our init method here. So now what we need to do is now we need to go ahead and create that events component. So to go ahead and do that, let's go ahead and go into our components. We'll make a new folder. We're going to call this events. And we'll make a new file. We're going to call this event bus component. So let's go ahead and export out our class. And we'll add in our constructor. So now for our event bus component, we need a way to listen for events and to emit events. And there's a built-in class that we can use in Phaser to go ahead and create this component. And so we're going to use the Phaser events event emitter. And in Phaser, all of your game objects actually have access to this. So I'm going to go ahead and do so. I jump back to our game scene. I'm going to go ahead and recreate our enemy instance here real quick. So we have our IntelliSense. So we'll have our enemy. And now if I do on, what this does, this reference an event emitter that's associated with that game object that was created. And so this is already built into most of the things in Phaser, because we can also do that on our scene. So like on our scene, I can do this events and I can do on. Now I'm referencing the event emitter on my scene instance. And so this event emitter in Phaser is really robust, and we're going to go ahead and create a new instance that we can use for our purpose. And so to go ahead and do that, we're actually going to go ahead and just extend that game object. We're going to go ahead and extend that class. We'll do extends, we'll do phaser, events, and we'll do our event emitter. So what we'll do in our constructor is we're just going to go ahead and call super to go ahead and call our parent constructor. And so now that we have our base component down, what we need to do is now we need to add in our events that we want to go ahead and listen for. And so what we're going to do is we're going to create an object of our event types that we'll support. So we'll do export const. We're going to do custom events. And so we're going to set this equal to object freeze. And so this will be an object. And so we'll do enemy init. And for our keys and values, these will just be the event types that we support. We'll use the same value as our key. And then we're also going to add one for enemy destroyed. And so what we'll be able to do with this event later is that's how we're going to control when we play our animation for where ship explodes. And we can use that for keeping track of like points. So if an enemy is worth so many points, they're destroyed, we can increment a score mechanic later. So now with our new event bus component, what we want to do is we want to make this reusable across all of our components. And so we're going to go ahead and create an instance of it in our game scene, and then we're going to pass it through to any other components that need it. So what we'll do is let's go ahead and comment back out our enemy code here. So right before we create our player, we'll create a new event bus component. So we'll go ahead and do const, we'll do event bus component. It's going to be equal to a new event bus component. And now what we can do is we can pass that through to our spawner components. And so we'll go ahead and do that. And so we'll have our event bus component, and we'll pass that to both of our instances. So now back on our enemy spawner component, let's go ahead and add that as an argument to our constructor. So we'll have our event bus component. And then what we'll go ahead and do is we're going to go ahead and pass that through to our enemy when we initialize it. So now what we can do is in our fighter enemy class, for example, let's go ahead and add that as an argument. So then what we'll do is we're going to go ahead and store a reference to this on our class, and then we'll go ahead and emit our new event. So let's make a new private property. We're going to do event bus component is equal to our event bus component that we passed through. Let's come to the top of our class, and we'll go ahead and add in that property. We'll also do that to our scout enemy. And then so what we can do in our class is at the bottom of our init method, we're going to go ahead and emit our event. So to do that, we're going to reference our event bus component. We're going to go ahead and use the emit property. And then what we'll do is now we go ahead and pass through our event. And so now we're going to reference our custom events, and we're going to use the enemy init. And so what we'll also want to do is we're going to want to pass through our enemy instance. So then that way we have it for reference anywhere that we need it. And so we'll go ahead and pass through this. So let's go ahead and copy that. We'll come over to our scout enemy class. We'll go ahead and paste that as well. And then let's go ahead and make sure we import our custom events. And then we're going to come back to our game scene. So now that we're emitting our events, now we need to actually listen for them in our scene. So now we can react to it. All right, so what we're going to go ahead and do is now we need to listen for our event. So we'll go ahead and do our event bus component. We're going to do on. Now we need to reference our custom events, and we'll do enemy init. And then we have our callback function that will be invoked when this event fires. And so we know we're going to receive an instance of our enemy because we passed through our game object. And what I'm going to go ahead and do is I'm going to do console log, and I'm going to go ahead and console log at our game object. All right, so go ahead and save and test. What we should see is as our enemy spawn in our game, we now see our console log for our new game object. However, we do see another bug happening, and what that is every time one of our enemies shows up in our game, we're now invoking our init method for our callback here. And so what's supposed to happen is we want to reuse our game objects, but what we're seeing here is we're creating a bunch of new instances. And what's happening is for our enemies, when they're not destroyed, once they get off our screen, we have no way to destroy them. And so we're going to need to add logic for once they're off our screen, we want to go ahead and make them inactive, so we'll be able to reuse those. And so before we do that, let's go ahead and finish up our logic before we add our overlap for our enemy's weapon, and then we'll go ahead and fix that bug. So what we'll do is in our game scene, what we want to do is for when we have our enemy in it, we want to go ahead and check which type of object it is. And if it's our fighter enemy, that's when we'll go ahead and do our check for our overlap for our enemy's weapon group and our player. So what I'm going to go ahead and do is I'm going to uncomment this code here. I'm going to go ahead and copy that code, and we're going to go ahead and move it inside our event listener here. So then what I'm going to go ahead and do is we're going to add if statements. We'll do if our game object. We're going to reference the constructor on our game object, and then we'll grab the name. And so if our constructor game object name does not equal our fighter enemy, then what we'll go ahead and do is we're just going to return early because we don't need to add that check because our other enemy type doesn't have a weapon. So we'll go ahead and do return. So then what we'll do is we'll have our physics overlap. We'll have it between our player. So instead of enemy, we'll have our game object, our weapon game object group. We'll have our player, our projectile, then we should have the same logic here. Then we should go ahead and change our enemy reference here. We'll go ahead and save. So what we should be able to do now is in our scene, if we go ahead and have our player line up so we get hit by our enemy's bullets, we'll see now we're taking damage on our ship. So now for our other bug, what we'll want to do is let's jump over to our enemy spawner component. And what we'll do is in our world step update, this is where we'll add that check to see if our ships are off our screen. Then we'll go ahead and make them inactive so we can reuse them. All right, so then what we'll want to do is now we need to grab all of our children game objects and see if they're actually active. So we'll go ahead and reference our group. We'll call the getChildren method. And then we're going to use our forEach method to loop through them. So then for each enemy, what we'll go ahead and do is we're going to make sure they're active. So if our enemy is not active, we want to go ahead and return. If the enemy is active, now we need to check their position. So what we'll do is we'll check our enemy's Y position. And so if it's greater than this scene, our scale, and our height, and we're going to add a buffer. So we'll add 50 pixels. So then that way we know it's completely below the bottom of our screen. Then we want to go ahead and make them not active. And so what we'll do is let's jump over to our fighter enemy class. I'm going to copy these 2 lines of code here. We're going to go ahead and paste it. And so we'll change our reference from this to enemy. And we don't want them to be visible and we don't want them to be active. So then what I'm going to do is I'm going to go ahead and add a console log to our create callback here. And we're just going to log out our enemy game object that was created. So now back in our scene, we should be able to go ahead and test. So we'll see our scout enemy spawns, our fighter enemy spawns, and then our new scout spawns, and then our new fighter spawns. And we still only have 2 instances of our game objects just like we want. All right, so one last change we're going to do is going to be tied to our fighter enemy and our scout enemy classes. So we restructure some of our code for how our enemies spawn, and what we're going to go ahead and do is we're going to add a safeguard to our update method to make sure this doesn't run until after our edit method has already been ran for our game objects. And so when we create an instance of our game object, because our group is automatically calling the update method for us automatically for each tick of our game loop, we want to make sure that our update loop doesn't actually run until we have all of the components and everything's been set up for our game object that we expect. And so what we're going to do is we're going to go ahead and add a property to our classes to keep track of this game object's been initialized, and only if it has, then we're going to go ahead and do this check here. So what we're going to do is we're going to come to the top of our class, and we're going to go ahead and add a new private property, and we'll do is initialized. And what we'll do is in our constructor, we're going to go ahead and set that equal to false. So what we'll do is right at the top, we'll do this is initialized. We're going to say equal to false. And then we'll come down to our init method. And at the very bottom, after we do everything we need, we're going to go ahead and set it equal to true. So now what we can do is in our update method, we're just going to add that safety check and we'll say if. So if this is initialized as false, we want to go ahead and just return early. All right, so let's go ahead and copy that. We'll come over to our scout enemy class. Let's go ahead and paste that in our update method. And then we'll go ahead and add the same logic that we did in our other class. Let's copy this, come over to our init method, we'll go ahead and paste it. We'll come up to the top of our class. And then finally, let's go ahead and grab the value from our constructor, and we'll go ahead and set it. All right, so all we're doing there, that's just a safeguard, just so we don't have any race conditions. So then that way, any components we want to reference, we already have them, and we know our game object's all ready to go for our scene. All right, so before we start working on our next component, what we're going to go ahead and do is we're going to go ahead and address a bug in our code tied to our overlap checks. And so currently, after our player is destroyed, what happens is our physics body still checks for overlaps between our player and our enemy game objects. And so what we're going to do is we're going to add a safeguard to our overlap check in our game scene. And then that way, if our objects are not active, we won't actually call our logic to go ahead and destroy the enemy ships or the bullets. And so what we're going to go ahead and do is we're going to go into our overlap code here, and we're just going to do if our player game object active. So we're going to say if our player game object is not active or the enemy game object is not active, then we'll just go ahead and return early. Otherwise, we'll go ahead and do our existing logic. So we're just going to copy this here. Let's paste it down here. And so that covers our groups. And now we want to go ahead and do the same thing down here when we check for the overlap between our enemy's weapon pool and our player. And so we'll have our player game object, and we want to change this to our projectile game object. We're going to copy that. Let's come down to where we check for our player collision with our player's weapons and the enemies. And so we'll have our enemy game object if it's not active, or our projectile. And one more time for other group, we'll go ahead and save. So now if we go ahead and have our player get destroyed, let's go ahead and stay here in the middle. What should happen now is now when another object, so like these bullets here, they should go through our collider and our enemy should not get destroyed. So now that we fixed that bug, now we're going to go ahead and start working on our next component. And so what we're going to do is we're going to create another spawner component, and this one's going to be used for spawning explosions in our game. And basically what we're going to do is anytime one of our enemies are destroyed, we're going to spawn a new game object in that position, and it's just going to go ahead and play our explosion animation. And so these are going to be basic sprites that don't have any colliders tied to them. And so by doing this, it allows us to separate our object pool for our active enemies and our object pool for our explosions. And so this will be nice because when one of our enemies are destroyed, we immediately set it to not active. And what will happen is if we want to do our explosion at that point, we need to leave our enemy active but not have it move. And it starts to add some complexities to our code. By decoupling the two, we can have the two separate object pools, but we'll still have a really nice in-game effect, just with that extra game object. And so for this component, what we're going to end up doing is we're going to listen for our custom event for when an enemy dies, and then that's going to be used to trigger the creation of this new game object. And so to go ahead and do this, let's come over to our code. And under our source folder, let's go into our components under spawners, and we'll go ahead and add a new spawner component. And so what we're going to do, we're going to call this enemy destroyed component. And so what we'll do is let's go ahead and export our class. We'll export class. We'll do enemy destroyed component. Let's add in our constructor. And so for this component, what we'll need is we'll need our phaser scene for we want to go ahead and create our phaser group. So we'll have scene for one of our arguments, and then we'll also need our event bus component, so that way we can add that event listener. So we'll go ahead and add an event bus component, and then what we'll do is let's add both of these as properties to our scene. So we'll have our scene. We'll also have our phaser group for our object pool, and then we'll have our event bus component. So now what we'll do in our constructor, let's go ahead and assign these out. So we'll have our scene will be equal to the scene we provide. Our event bus component will be equal to our event bus component. And now we want to go ahead and create our phaser group. So we'll go ahead and do this. Group will be equal to our scene. We'll use the add method and we'll do group. Now we need our configuration. And so for our configuration, the only thing we're going to go ahead and use is name. And so what I'm going to do is I'm going to jump over to our enemy spawner component. I'm going to copy this here. We'll add it to our name. All right, so what we're doing here is we're creating a basic phaser group. And the reason we're not using a physics group is by default, if we don't provide a class we want to use for when we create our game objects, Phaser is going to go ahead and use a sprite game object for us. And for these explosions, we don't need any physics tied to them. They don't need a physics body. And so by using a regular group, we'll just create a regular sprite. And then we don't have to worry about physics being applied to them. All we care about is the animation component for that game object. So now that we have our group, now we need to go ahead and listen for our events. We'll do our event bus component, we'll do on, and let's go ahead and do our custom events. And we want to do enemy destroyed. So when our enemy is destroyed, we'll receive an instance of our enemy, and we'll have to add in this logic. And so once we have our enemy, now what we want to do is we need to grab a game object from our group. So what we'll do is we're just going to store that in a variable. So we'll do const, we'll do our game object is going to be equal to our group. We're going to use the get method. And now we want to go ahead and provide our X and Y value for where we want this game object to spawn in our game. And so we're going to use our enemy object as provided, so then that way we have the same X and Y position. And then we're also going to reference the texture that's currently applied to the enemy that was destroyed. And so for that, we're going to need to add a new property that we can reference to get that asset key. And so because currently our scout and our fighter use different assets, and we just want to go ahead and grab that from that class. And then we want to go ahead and use a frame. And so currently for both of our game objects, it's set up to use just the default frame. If we ever had a single sprite sheet with multiple frames, we would have to go ahead and refactor this so we can actually grab that frame from our class. But for the time being, this will work. So after we spawn our game object and we now have what ship it should look like, now we need to go ahead and play our animation. And so we're just going to go ahead and do play. Now we need to provide our configuration, so we'll have our animation key. And similar to like what we did before, now we need to know which animation asset key should be tied to the game object that was destroyed. So we're going to add this to our enemy classes as well, so then we have it for a reference. And so we're going to call this ship destroyed animation key. All right, so since we did that, let's go ahead and add these two getters to our two classes, so then we have them available. So what I'm going to go ahead and do is I'm going to jump over to our fighter class first. So we'll have our fighter enemy. I'm going to come down to the rest of our getters, and I'm going to do get. We'll have our ship asset key. And so for this, we're just going to go ahead and return fighter, since that's the asset key we're using when we create our main ship sprite. I'm going to copy this and paste it. And now we just want to go ahead and do our other getter. So we're going to go ahead and do our ship destroyed animation key. We'll have get ship destroyed animation key. And now for this, we want fighter and then destroy. And so these are just the asset keys that we have listed inside our data file for animations. We'll see that for each of our ship types, we have some type of destroy animation tied to them. So now what I'm going to do is I'm going to copy both of these. Let's jump over to our scout enemy class, and we're going to go ahead and paste those getters here. And now we just need to go ahead and update our references. So it's just going to be scout, and we'll have scout destroy. So now the next thing we'll need to do for our destroy component to work is we need to go ahead and actually emit this enemy destroyed event when our game object's actually destroyed. So let's jump over to our fighter enemy class, and what we're going to do is in our update method, when we have our check here to see if our game object is now dead, what we want to go ahead and do is we want to go ahead and play our animation. And so now what we'll do is we're going to go ahead and use that event bus component that we assigned in our init method here. So what we'll do is we're going to do this. We'll reference our event bus component, and we're going to do emit. And now we're going to go ahead and do our custom events, and we want to do enemy destroyed. Now we're going to pass in this as a reference, so then that way this instance of our fighter enemy will be available to our component here. So now what we're going to do is we're going to copy this. Let's jump over to our scout enemy class, and similar thing, when our health component shows it's dead, we're going to go ahead and emit this event. So now we finished updating our enemies to go ahead and emit our new event. What we're going to go ahead and do next is now we need to go ahead and create an instance of our enemy destroy component. So what we'll do is let's go ahead and jump over to our game scene. And then what we'll do is after we create our enemy spawn components, we'll go ahead and make a new component. So we're going to go ahead and do new. We're going to do our enemy destroy component. And so for this, we'll pass in our scene. And then we'll go ahead and pass in our event bus component. All right, so now we're going to save. We should be able to test our changes. So in our game, let's go ahead and try destroying an enemy ship. All right, we'll see when our enemy's destroyed. We play an explosion animation right where the enemy was. And now if we check our console log, we'll see even though we're destroying our enemy game objects, we're still only spawning those same two game objects and we're reusing them. All right, so then one more test. We're going to go ahead and let the enemy ship go ahead and collide with us, and that should cause the enemy to explode, and our ship should explode as well. All right, so one last change we're going to go ahead and make to our game is we're going to go ahead and turn off our debug. Since we've tested our collisions, we're going to go ahead and turn off our purple boxes. So we come into our main.js, let's go ahead and set our debug to false. Now we should be able to go ahead and test our game without our debug information. All right, so now we wrapped up our section on our enemy spawners. What we're going to do next is we're going to start our UI and our audio section. And so in this section, we're going to go ahead and implement a scoring mechanic. So when our enemies are destroyed, we'll receive some type of score, and we're going to display that in our UI. We're going to implement player lives, so then that way we have multiple lives, and as our ship is destroyed, you can respawn. Then we're going to add in support for audio, and then finally we're going to enhance our game with some backgrounds to our canvas element. And so to get started, we're going to go ahead and knock out our backgrounds real quick. So what we're going to do is let's jump over to our game scene. And so in our assets folder, we have some very nice background sprite sheets here that we're going to go ahead and apply in multiple layers to get a very nice looking background. So what we're going to do is at the top of our create method, we'll go ahead and create these three game objects. And so for our background, we're just going to go ahead and use sprites. We're going to do this, we're going to add, and then we'll do sprite. And so for our sprite, we want to position these in the top left-hand corner. For our asset key, it's going to be BG1, 2, and 3. And then each of these, we're going to use frame 0. So then what we're going to do is we're going to go ahead and update our origin. And so for our X, we'll go ahead and do 0. So then that way it's on the left. And then for our Y value, we're going to have it at 1. So then that way it's all the way at the bottom. Next, what we're going to go ahead and do is we're going to go ahead and update our alpha. And so we'll do set alpha. We're going to do 0.7. And so this is just going to make the images a little bit transparent. And then that way they can show through each other and we'll be able to see each image. Next, we're going to go ahead and we're going to go ahead and rotate them. So we're going to go ahead and do set angle. And we're going to go ahead and do 90 for 90 degrees. And so the reason we're rotating our game objects is our sprite sheets that we're using, they are long images. And so they're meant to be displayed when our game width is greater than our height. But we actually have our properties reversed, so our game is higher than our width. And so by rotating these, we'll get a very nice effect. Finally, we're going to go ahead and set scale, and we're just going to go ahead and scale these up by a little bit for our Y values. We're going to do 1.25. So now if we go ahead and save, we should see our first image appear on our scene, and so we have like this purple looking smoke. So then what we're going to go ahead and do is I'm going to copy that. I'm going to go ahead and paste it a few times, and then we're just going to go ahead and add BG2 and then BG3, so they're layered on top of each other. All right, and so these are animated. So what we're going to go ahead and do is then for each of these, we're going to go ahead and play an animation. And so what we're going to go ahead and do is we're going to do play. And then for our animation name, it's going to go ahead and be the same as our texture. And so we'll do play BG1. Let's copy that. We're going to go ahead and paste it a few times. And let's do 2 and 3. Now when we save, we should get this really cool animated background. And we'll see everything's moving. All right, so the next thing we're going to work on is we're going to add support for a score mechanic into our game. And so what we're going to do is we're going to create a simple UI component that's going to listen for when our destroyed event is emitted. And when that happens, we're going to check which enemy was destroyed and update our score. And so for this to work, what we need to do is for each of our enemies, we need to actually give them a score value for how much their points they're worth when they're destroyed. And so what we're going to go ahead and do is in our config, let's go ahead and start with our enemy fighter. I'm going to copy this line here. And so instead of health, we're just going to say score, and we're going to say they're worth 200 points. Then we're going to go ahead and do the same thing for our scout. And so we'll have enemy scout score, and we're going to say 100 points since they don't fire back at us. And then what we'll do next is now we need to add in our phaser game text object to go ahead and display our score and to keep track of it. And so what we'll do is we're going to make a new class to keep track of all this. So what we'll do is under our objects, let's make a new folder. We're going to call this UI. And then what we'll do is let's make a new file. We're going to call this score.js. And so what we'll do is export our class score. And for this, we're going to go ahead and extend our phaser game object, our text game object. So then that way we can just use that to keep track of this. And so let's go ahead and do extends. We're going to do our phaser, our game objects, and then we'll go ahead and do text. So now for our text game object, we'll need our constructor. And so for us to add this to our scene, we'll need our phaser 3 scene. And then for us to go ahead and listen for when an enemy is destroyed, we're going to need that event bus component. And now because we're extending our text game object, we're going to go ahead and use super. And then for our scene, we'll pass in our scene. For our position, we're going to go ahead and position it in our top of our game in the center. So we'll go ahead and use our scale manager to go ahead and grab our width. And we're going to go ahead and divide it by 2 to center it. We're going to do 20 pixels down from the top. And then for our text, we'll go ahead and just start with a 0. And now what we'll do is let's go ahead and add some styling. So let's do our font size. We're going to go ahead and do 24 pixels. And then for our color, we're going to go ahead and do FF, 2F, and then 66. And so we'll get this nice looking like reddish pinkish color. And then because we extended our game object, we need to go ahead and add it to our scene. So we'll do this. We're going to go ahead and reference our scene. And then we're going to go ahead and add existing. And we'll go ahead and add in this game object. So let's go ahead and store a reference to our event bus component. We'll set that equal to our event bus. And let's go ahead and add this property to our class. And then what we'll also want to do is we're going to want a property to keep track of our score. So we'll go ahead and add one more property. We're going to call this score. And we're going to go ahead and set that equal to 0 in our constructor. So then for our score game object, what we'll do is let's go into our game scene. Let's go ahead and create an instance of it. So we'll come down to the bottom of our create method after our colliders. And let's do new. We'll do score. We'll pass in this, and we'll pass in our event bus component. So now what should happen is now we should see our 0 appear in our scene. And then what we're going to go ahead and do is we're going to go ahead and update our origin. So then that way it's centered. So we'll go ahead and do this. We'll do set origin, and we'll do 0.5. Then that way our text game object is centered directly in our screen. All right, so now that we can see our text, now we need to go ahead and update it when one of our game objects is destroyed. So what we'll do is we'll go ahead and use our event bus component. And so for our event bus component, we're going to use on, and now we need to reference our events, and we want the enemy destroyed event. And so we're going to go ahead and receive our enemy game object. And now for our enemy game object, we need to go ahead and grab the relevant score. So we go ahead and increment that. So what we'll go ahead and do is we'll reference our score property, and we're going to go ahead and increment it by the value of our enemy. And so for our enemy, what we need to do is associate the class name with our config. And so we're just going to go ahead and create a variable to do that. So we're going to do const, we're going to do enemy scores is going to be equal to this object. So we'll have our scout enemy. And so for that string, we want this to be equal to our config. Next thing, I should go ahead and import that in. So we'll do import. star as config from dot slash and config.js. So now what we should be able to do with our IntelliSense, we'll have config, and we want our enemy, scout, and we want our score. So let's go ahead and copy this, and we want to go ahead and do the same thing for our fighter. And so we'll have our enemy, fighter, score, and now we want our fighter enemy. So now what we should be able to do is down back here where we're going to increment our score. Now we're going to go ahead and use our new enemy scores object. And for our property, we're just going to use that enemy. We're going to use the constructor. We're going to grab the name from that game object. And now that we've incremented our score, we need a way to go ahead and update our text game object. We want to update that text value. And so we're going to use this set text. And so this lets us update that string. And so we're going to go ahead and do this. We'll do our score. And because this is an integer, we're going to go ahead and do toString. So now it's a string. Oh, and real quick, we'll fix our import, and then we'll go ahead and save. So now if we want to go ahead and test our changes, let's go ahead and just try destroying one of our ships. We destroyed our fighter. We got 200 points. Oh, we got 100 points there, 200. Ah, yes. Okay, so when we saved, our formatting got messed up. We actually want this to be plus equals. So now we're incrementing. All right, so now we should go ahead and test our changes again. So let's go ahead and try destroying one of the ships. All right, we get 100. Now we're up to 300. All right, very nice. All right, so now that we have our scoring working, next we're going to go ahead and work on implementing our player lives feature into our game. And so for this, what we want to do is we want to have a UI component that's going to display how many lives our player actually has left. And then when our ship is destroyed, we want to go ahead and decrement that and then respawn our player. And then once we run out of lives, we're going to go ahead and have the game actually be in a game over state. And so we'll go ahead and display a message to the player. So for us to do this, we're going to go ahead and add some new events to our event emitter. And so what we'll do is let's go ahead and open up our event bus component. And we're going to want to know when our player spawns and when it's destroyed. And then that way we can go ahead and once our player actually spawns, we'll be able to re-enable input. So then that way our player can move around our scene. And we'll be able to use the player destroyed event to keep track of our lives and decrement them when this happens. And so to go ahead and do this, what we'll do is we're going to go ahead and add in player, and we'll do spawn event. We're going to add in player destroyed. And then finally we're going to add one for game over, which will be emitted once we are destroyed and we have no lives left. So for our values, let's go ahead and use the same string. So now what we'll want to do is let's go ahead and open up our player object class. And then what we'll do is now when our ship is destroyed, we're going to go ahead and emit an event that our ship was destroyed. And so for us to go ahead and do that, we'll actually need to receive an instance of our event bus component. So what we'll do is let's come to our constructor. After we get our scene, we'll go ahead and add in our event bus component. So let's go ahead and add a property for this to our class. So after our collider component, we'll have our event bus component. And then what we'll do is let's go ahead and assign that property to our event bus component. And now what we'll do is let's come down to our update method when our ship is destroyed. And so after we start playing our animation, let's go ahead and reference our event bus component. We'll go ahead and emit an event. And let's go ahead and import our custom events. And now we want to go ahead and do player destroyed. So now what we'll do is let's jump back to our game scene. We'll go ahead and update our player to have our instance of our event bus. So we'll have this, and then we'll have our event bus component. All right, so the next what we'll need to do is now we actually need to create our component for our lives. And so what we'll do is let's go into our objects. Let's go into our UI folder. We'll go ahead and add a new file and we'll call it lives.js. And so now for our lives, what we're going to do instead of using a text component, we're actually going to display player ships down our corner like old arcade machines. And so for each of our ships, we'll have a life. And so to do that, we'll go ahead and export our class. We're going to call it lives. And we're going to go ahead and extend our Phaser game objects container game object. And so we'll do our game objects. Let's do container. And now we'll need some properties. We'll have a lives property to keep track of how many lives we have left. And then we'll need our event bus component so we can listen for that event that we just emitted. So let's go ahead and add in our constructor. And so for this, we'll need our Phaser scene, and then we'll need our event bus component. So we'll go ahead and call super, and now we need to pass in our Phaser scene. And now for our positioning, we're just going to go ahead and position in our bottom left-hand corner here. And so we're going to do 5 pixels, so we're a little bit over. And now we're going to go ahead and take our scene, our scale manager. We'll go ahead and grab our height. And then what we'll do is we're going to subtract 30, so then that way it's not right at the bottom, it's going to be a little bit up. And then finally, we're going to go ahead and pass an empty array, since we have no game objects to currently add to our container. Let's go ahead and update our event bus component to go ahead and have a reference to our event bus. And now we need to go ahead and set our lives. And so for our lives, what we want to go ahead and do is we're going to add a new property to our config. And so we'll do config, and we're going to call this player lives. So what I'm going to do is I'm going to jump over to our score class. I'm going to copy our config real quick. Go ahead and paste that in. And now let's go ahead and jump into our config. And at the top of our file, we're going to do export const. We'll have player lives, and we're going to go ahead and do 3 lives. So now if we jump back to our lives class, what we need to do is now we need to add our container to our scene. And so we're going to do this.scene, add existing, and we want to add this to our scene. So now that we've added our container, now we actually need to add our image game objects into our container. And so what we'll do is we're going to use a for loop. And so we'll do for let I equals 0 if I is less than our number of lives that we get from our config. Then we want to go ahead and increment this by 1. And so here we're going to go ahead and create a new image. And so we'll do ship. We'll go ahead and do scene, add, do an image game object. And so for our image game object, for our position, we're going to use our index and our for loop to figure out how far over for our x we want to position our icons. And so for our first one, it'll be like here, then here, then here. And so to figure that out, we're going to use our I index. We're going to multiply it by 20. And then what we'll do is for our Y position, we're going to use 0. And now we need to use our ship game asset. So we'll be using the same asset as our player ship. And now we want to go ahead and scale it down a little bit so it's not so big. So we'll do set scale. Let's do 0.6. And then we'll do set origin. And so we'll do 0. That way it's in the top left-hand corner. And now we need to go ahead and add that to our container. And so we'll do this, add, and we'll add our ship game object. Go ahead and save. Let's come over to our game scene, and we'll go ahead and create an instance of our new class. So after our score, we're going to do new, lives, this, and our event bus component. And as soon as we save, we should see now down in our corner, we have our 3 icons representing our player lives. All right, so next what we need to do is now we need to add our event listener for when our player is actually destroyed. And when it is destroyed, this is when we'll go ahead and update our lives. And then we'll go ahead and respawn our player ship. And so after our for loop, what we'll go ahead and do is let's reference our event bus component. We're going to use the on method. Let's grab our custom events. And now we want to go ahead and listen for our player destroyed event. So when this happens, in our callback, we're going to go ahead and update our lives. So we'll have this.lives. We're going to go ahead and decrement it by 1. And now we need to delete one of our image game objects. And so what we'll do is we're going to do this. We're going to do get at. Then we're going to go ahead and reference our lives. And then we're going to call the destroy method. And so what getAt does, it allows us to grab our game object from our container based on its index. And so when we add game objects to our container, Phaser keeps them in the order that we add them as their index. And so as an example for our first ship here, it'll be at index 0. And then once we get to 1 for our next live, it'll be index 1, then 2, and then 3. And so by us using our lives as our index, what we're able to do is we can destroy the last game object here on our container. And so if we're going to test this real quick, we'll go ahead and have one of our enemy ships appear, and then we'll go ahead and have them collide with us, and we'll see our game object is now destroyed. All right, so what we'll want to do is if we have more than 0 lives, we'll want to go ahead and emit an event so we can respawn. And if we have no lives left, then we want to go ahead and display our game over text. And so what I'm going to do is I'm going to add an if statement. We're going to do this. We're going to reference our lives. If it's greater than 0, then we want to go ahead and emit our event for respawning our player. But we don't want to do this right away. We want there to be a little bit of a delay, so then that way it takes like a second for our ship to respawn. And so to add that type of delay, we can use our time plugin. And on here we have a method called delayed call. And what this does, it allows us to provide a callback that'll be invoked after a set number of milliseconds. And so we're going to do 1,500, so 1.5 seconds. Then for our callback, this is we'll go ahead and emit our event. So we'll do our event bus component. We'll do emit, and we'll do our custom events, and let's do player spawn. So once we do that, we'll go ahead and return. And now what we need to do is if we don't have any lives left, let's go ahead and display a text game object that says, hey, the game is over. And so we'll do this. We'll do our scene, add, and we want to add a text game object. And so for our position, we want it right in the middle of our screen. So we're going to reference our scene, scale, our width, we'll divide by 2, and we'll do our scale. So we'll do this scene, scale, let's do our height, divided by 2, And for our text, we're just going to do game over. And for our styling, all we're going to do is set our font size. And we're going to set this to be 24 pixels. And then we're going to go ahead and update our origin, so then that way it's actually centered, and we'll do 0.5. And then what we want to do is now we want to go ahead and emit our event that our game's over because there's no lives left. And so we'll do event bus component, emit, and we'll do our custom events, and we're going to do game over. All right, so if we go ahead and save, what we want to go ahead and do is first, let's go ahead and test our game over text. So if we come over to our config, I'm going to go ahead and bump our lives down to 1. All right, so what I'm going to do is I'm going to go ahead and save, and if we go to test real quick, let's go ahead and have our ship get destroyed. What should happen is we should run out of lives, and now we have our game over text appear. Nice. So I'm going to go ahead and revert that back to 3, and what we want to do now is we need to update our player class to listen for the spawn event, and when it happens, then we want to go ahead and have our game object reappear with all of our components reset to their initial state, so that way our health is back at the max. So to go ahead and do this, what we'll do is we'll come to our constructor, and we're going to go ahead and listen for that event. So we'll do our event bus component. Let's do on, and so we'll go ahead and have our custom events. We'll do player spawn, and so when our player spawns, we'll go ahead and call a new private method. So we'll do this.spawn, and then we'll pass in our context of this. So I'm going to go ahead and copy this. I'm going to come down to the bottom of our class. I'm going to go ahead and add that new method. So we're going to have spawn. And so when we spawn our game object, we want to do the opposite of our hide method here. And so I'm just going to copy these here. And so what we'll do is when we spawn, we're going to make us active. We'll make us visible. Then we want to go ahead and do the opposite of these as well. So we're going to paste those. So for our ship engine sprite, we're going to go ahead and set that equal to true. We'll make our thruster sprite visible as well. And then for locking our input, we're going to go ahead and unlock it. So we'll set equal to false. Some other things we're going to want to do is because for our ship, we do our destroyed animation, we want to go ahead and reset our texture back to our first frame, and we want to reset our texture back to our ship. And so we'll do this. We're going to go ahead and do our ship sprite. We're going to do the set texture method. And so we're going to go ahead and set this back to ship, and we want to go ahead and do 0 for our frame. Now we want to go ahead and reset our health component. And so we'll do this, our health component, we're going to call reset. And then finally, we want to go ahead and update the position of our game object so then that we spawn right back in the center of our screen. And so to do that, we're just going to do this. We're going to call set position. And now we want to go ahead and do the same position of where we spawn our player in our constructor. So what I'm going to go ahead and do is I'm going to come up here, and I'm going to copy these pieces of code. We'll come back down here, and we'll go ahead and paste those. And then we just need to update our references. So we'll have our container, this.scene, and then this.scene. So now to go ahead and make this consistent, what we're going to go ahead and do is we're going to hide our game object right off the bat. And so before we register our event meta, we're just going to do this.hide. And what we're going to do is from our lives component, we're going to have this actually trigger spawning our player game object. And so to go ahead and do that, we're just going to go ahead and emit our spawn event. And then this is going to allow us to test it without being destroyed. So we'll see right away when our scene refreshes, our player ship is now back in our scene. And if we go ahead and get destroyed, we should be able to test our logic. So we'll go ahead and collide. We'll see our player gets destroyed, our live gets decremented, and now our ship is back in our scene. And even though we died over here, our ship is now back in the center of our screen. And finally, if we die one more time, we should see our game over text. Nice. All right, so one more change we're going to do is once we get to our game over screen, we're going to go ahead and stop spawning our enemy game objects, and then that way they just stop appearing in our game. And so to go ahead and do this, we're going to listen for our game over event in our spawn component, and when it's triggered, we're going to go ahead and disable our spawning. All right, so to go ahead and do this, let's go ahead and go into our enemy spawner component. And the first thing we're going to do is let's add a new property for this. And so we'll have a new private property. We're just going to call this disable spawning. In our constructor, we're going to go ahead and set this to be false by default. So we'll do disable spawning equals false. And now what we want to go ahead and do is now we want to listen for our event from our event bus. And so we're going to go ahead and do our event bus component. We're going to go ahead and do on, and now we need to listen for our custom events. And when our game over event is emitted, we're going to go ahead and set that property to be true. So we'll go ahead and copy that. Let's go ahead and paste it. And now what we'll do is down in our update method, we're just going to do a check to see if this is set to true, then we're not actually going to do anything. So down in update, so we'll do if this disable spawning is true, we'll go ahead and just return early. And so by doing this, we can easily enable and disable this, so then that way later on, we can allow a player to continue, and then we can just start respawning enemy game objects all over again. Alright, so since we've wrapped up our player lives and our scoring mechanics, the next thing we're going to do is we're going to focus on adding in our game audio to our game. And so in our assets.json file, when we load in our assets, we're currently loading in a bunch of audio files that we're not using in our game. And so what we're going to do in this video is we're going to go ahead and add a new audio manager. And what this is going to do is we're going to listen for various events in our game, and we're going to go ahead and respond to those events and play different sounds. And so what we're going to do is we're going to add support for an explosion for like when one of our enemy ships are destroyed, when we fire our weapon, or even when we hit an enemy ship. And then we'll also go ahead and just add some nice background music that'll play while we're playing our game. And so for our audio manager, what we're going to end up doing is we're just going to go ahead and use our event bus component that we've been using for our other components. And we'll also add in some new custom events that will fire from like our weapon component and from our collider component. And so to go ahead and get started with all these changes, what we'll do is let's go ahead and start in our event bus component. And what we're going to do is we're going to add 2 new events so that we can track when we shoot our weapon and when we go ahead and hit an enemy ship. And so for these 2 events, we're going to go ahead and do ship hit, and we'll do ship shoot. So for both of these, we'll keep with our pattern. We'll have our value be the same as our key for our object. And now what we need to do is we need to update our components to go ahead and emit these when they happen. And so what we'll do is let's go ahead and jump into our weapon component. And so in our weapon component, let's come to the top of our class. We'll go ahead and add a new property to keep track of our event bus component. And then what we'll do is we'll add that to our constructor so we can provide it when we create an instance of our component. And then what we'll do is we'll go ahead and assign that. So we'll do our event bus component will equal to our event bus component that we provide. And then what we'll do is let's come down to our update method. And so when we fire our bullet and we play our animation, we'll go ahead and emit our new event. So we'll go ahead and use our event bus component. We'll use the emit method, and let's do our custom events, and we want to do ship shoot. So now for when our ship actually gets hit, we need to go ahead and update our collider component so we can go ahead and send out that event. So let's go ahead and jump over to that component, and we'll also go ahead and add our event bus here. So what we'll do is I'm just going to copy this from our weapon component. We'll add that to our collider, and we'll do the same thing for our constructor. And so we'll go ahead and change this to, we'll go ahead and add that to our constructor. And so now what we want to do is when we collide with our enemy projectile, we'll want to go ahead and emit that event that we just got hit. And so we'll go ahead and do our event bus component, emit, we'll do our custom events, and now we want to go ahead and do ship hit. All right, we'll just make sure our file extension is correct in both these files. All right, so now what we need to do is when we create instances of these components, we need to go ahead and pass our event bus through. So let's go ahead and start with our player. And so for our player, we'll go ahead and go to our weapon component. Let's go ahead and add in our event bus. Go ahead and do this, and we'll reference our event bus component and our collider component. We'll do the same thing. And now we want to go ahead and jump over to our enemy classes. So let's go ahead and start in our fighter class. So what we'll do is in our init method, when we go ahead and create our weapon component here, we'll go ahead and pass that in. And I'm just going to copy this, and we're also going to add that into our collider component. And now let's go ahead and jump over to our scout enemy class, and we'll do the same thing. So we will go into our collider component, we'll add that in, and we don't have a weapon component on this enemy, so we don't need to add that. All right, so now with our updates, now we need to go ahead and actually listen for these events, and then we'll go ahead and play our sound. So what we're going to go ahead and do is we'll make a new class for our audio manager. So we'll do is under our source folder, what we'll do is we'll go into our objects, and then for our objects, let's go ahead and add a new file, and we're just going to call it audio manager. So what we'll do is let's go ahead and export our class. We'll export class, audio manager. And so for our class, we're going to get in our event bus component. So we'll have our event bus component. Let's add our constructor. And now for our argument, we're going to need our phaser scene. And then we'll also need our event bus component. Then what we'll do is we'll also store a reference to our phaser scene. And so we'll just add scene. So in our constructor, let's go ahead and assign those properties. So we have scene will be equal to our scene. Then we'll have our event bus component will be equal to our event bus component. So now in our constructor, we need to go ahead and listen for those events that we're emitting, and we'll go ahead and play our audio files when this happens. And so to get started, the first thing we'll do is let's go ahead and listen for our ship destroyed events. And so what we're going to go ahead and do is we'll do our event bus component, we'll do the on method, and now we need to go ahead and listen to our custom events. And we'll go ahead and start with enemy destroyed. And so when this event fires, we're going to go ahead and use our sound manager from our scene, and we're going to go ahead and play our audio file we want to play. So to do that, we're going to reference our scene that's associated with our audio manager. And now we want to reference the sound manager, so we'll do .sound. And now we need to go ahead and use the play method. And so for this method, we need to go ahead and provide our cache key of where our audio file is stored. And so this is going to be explosion. And then we can also go ahead and provide any audio settings we want to apply to the sound effect when we play it. And so this allows us to do things like set the overall volume for when we play this. We can have our audio go ahead and repeat if it's like background music and different things like that. And so what we're going to go ahead and do is we're going to go ahead and set volume, and we're going to go ahead and set this as 0.6. And what volume does is we can provide a value between 0 and 1, and that's going to go ahead and allow us to modify the volume of the audio we're playing. And so if we have a default value of 1, we're going to play it at the regular level of whatever the audio file is. And we can, if it's a loud file, we can go ahead and scale it back by setting our volume to less than 1. And it's going to go ahead and make that sound be a little more quiet. So what I'm going to go ahead and do real quick before we test is let's just copy this, and we'll also add in one for when our player is destroyed. So we go ahead and play the same sound. All right, so for us to go be able to test, let's go ahead and jump into our game scene, and we'll go ahead and create an instance of our audio manager. And so what we'll do is let's come down to the bottom of our create method. Let's do a new audio manager. Let's go ahead and pass in our scene and then our event bus component. And then we'll jump back to audio. Oh, need to fix our import. Let's go ahead and save. All right, so now if we have one of our ships get destroyed, we should be able to hear our sound effects. So we'll see when our enemy's destroyed, we play, and then when our player's ship is destroyed, we also play an audio sound. All right, so now we can see that our sound's actually working from our audio manager. What we're going to go ahead and do next is we'll listen for other events, and we'll play our other audio effects. So what I'm going to go ahead and do is I'm going to copy this line of code here, go ahead and paste it, and so what we're going to do is we're going to listen for one of our ships get hit by a bullet, and so we'll do ship hit, and then we're going to go ahead and play our hit audio sound. And then what I'm going to go ahead and do is I'm going to copy that, go ahead and paste it, and then we'll also do ship shoot, and we'll go ahead and do shot 1 for our audio asset. We'll go ahead and save. And so what we should be able to do now is we should be able to go ahead and test. So now we can hear when we shoot our bullets, we can hear our sound effect. And so we can see that's kind of loud. And so what we're going to do is we're going to bump this down even lower so it's not so loud for our game. So we're going to do 0.05. And so now we shoot, we'll see our sound has now been, it's a lot. So what we'll see now is when we fire our bullets, our sound is a lot lower compared to our other audio assets that we're playing. All right, and so the last thing we're going to go ahead and do is we're going to go ahead and add some background music to our game. And so to go ahead and do this, what we'll do in our constructor is as soon as we create an instance of our audio manager, we'll go ahead and start playing our background music. And so to go ahead and do that, we're going to reference our scene, and then we'll use the play method. We're going to use the audio asset BG. And then for our configuration, we're going to go ahead and set our volume to 0.6. And then one other thing we're going to do is we're going to set our loop property, and we're going to go ahead and set this to be true. And so what loop does, it allows us to go ahead and loop this audio asset, so as soon as it finishes, it'll go ahead and repeat. Oh, and then our code, so not scene.play, should be scene.sound.play. All right, as soon as our scene refreshes, we should now hear our background music playing in our scene. All right, so those last changes for our game audio, that actually wraps up our tutorial series on creating a space shooter with Phaser 3. So in this series, we covered a number of different topics, and we focused on building reusable logic that we could put into components that we could add to our game objects. And we saw how we could use the Phaser built-in arcade physics and other features to build this really cool game. And so I hope you really enjoyed the series. And so with the game that we created, it's a very basic game. What we could do now is you could take your game and you could actually take it further by adding new features and refining it, and you can really make it your own. And so some ideas for how you could go ahead and enhance the game is you could add weapon power-ups. And so as we destroy enemies or reach certain scores, we could power up our weapons, and that can make them stronger. So maybe like shoot 2 bullets at a time or 3, different bullet types like lasers. We could go ahead and add in support for mobile, so you can actually play it on a mobile screen and have it be mobile responsive. We could add in new enemy types, and we could also add in like boss enemies that could have different attack patterns and have like a health bar. For our spawners, we could change it so we actually spawn waves of enemies. So maybe like be a wave pattern where there's like 3 enemies in a row and different things like that. For the scoring mechanic, you could implement a high score feature so we persist this between sessions, and we could show the high score when we get to our game over screen. We could then also work on difficulty. So right now the game is very simple where we just have our enemies keep respawning and they don't actually get any more difficult. So long as we can dodge them, the game difficulty stays the same. And then we can also add in other mechanics like a shield. And so we pick up the shield, we'll be invulnerable for a period of time. Maybe when we spawn, we have a shield for a few seconds before it disappears. And then finally, we could actually refine the game by adding additional scenes. And so we could add like a title screen, we could add in like options, credits, and different things like that. Because there's lots of things we can do to improve this and then really take this game further. And so if you do decide to take this game further and add more features to it, I'd be definitely interested to know and seeing what you build. And so if you do decide to extend this game and add more onto it, I'd definitely be interested in knowing and seeing what you build. So if you do, please let me know in the comments down below. Alright, so with that actually brings this video to an end. So thank you again for watching this series, and as a reminder, there's a link in the description of this video to the complete source code for this video and for the full game project. And as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when my next video is released. For more great Phaser 3 content, please see the links on your screen now.